Hi friends, this is Pradeep once again. Today I am going to solve GATE 2006 question paper, and this belongs to mechanical engineering branch, so I will be solving this question paper for mechanical GATE 2006. So in the previous question paper, I think 2003, 2004 and 2005, I have already uploaded it, you can check it. So let's start. Okay, let's start here. Let's see question number one. Yeah, one more thing. If you want to download this question, you can download from a website called gate2016.com or so. I will be provide you the link in my description. So you can download it and you can solve from your end. And once again, I should for the people who are new to my channel, let me tell you that this represents the solution and this is the question paper which I am going to solve. And I will be using two colors, say marker, and wherever I will be require, I will be using pens also. And and I am many people still asking me that why you are not solving question from backward, that is gate 2020, gate 2019, gate 2018. This is because I want to go, I intentionally chose to go in a chronological fashion so that I can show you what all things that has been asked in past is actually they are asking in the next year or so. So in this way we can try to establish the correlation between the things that has been asked in past and what they can ask in the future gate paper. Okay, so anyways, and a few of the questions for few of the questions I have not explained it in the past question paper. I just put the formula and got given those answers. Now in the next coming gate questions I will be giving you some proofs of those and with the full explanation. For example, in the previous question paper gate 2005 there was a question related to the turbine blades, the turbine blade diagram. I have not proved it, just I have established the relation between looking at the blade lengths. I established the relation and find which type of turbine it is. Now in this question paper a similar type of question has been asked, so for that I tried to establish a relation, how the blade angles have been made, how it is determined, and how to determine the corresponding work done by the turbine or so based on the velocity diagrams. Okay, so stay tuned to my channel, subscribe it, so that you can get more updates regarding the gate previous year question solution as well as make other mechanical stuffs. I will let you know what all those mechanical stuff that I will be bringing for you. So let's start question number one. They have given some numerical method on the left hand side, and the third and the in the column 2, what actually it is used for, to find out. So I directly wrote the answer. Gauss Seidel method is used for linear algebraic equation solution. Forward Newton-Gauss method is for interpolation based on interpolation theory. Then Runge-Kutta method is used for non-linear differential equation solution of non-linear differential equations. Trapezoidal equation is for numerical integration. So with the coming with the coming upcoming gate questions, we all will be dealing with this type of question in the numericals. Okay, so we will get to know how these things are done. Now question number 2, the solution of the differential equation dy by dx 2xy is equal to e to the power of x square. Now here you will see it is in the form of dy by dx plus p of y plus q of x. So first we will find integrating factor, that is e to the power of integration p dx. Okay, so we find to e to the power of 2x dx is equal to e to the power of x square. And then what we will do, solution of the equation is just multiply with the base equation. When you multiply with the base equation, it becomes e to the power of x square dy by dx plus 2xy e to the power of x square is equal to 1. So if you observe it carefully, you find that this is nothing but the dy by dx of e to the power of x square y is equal to 1. When I solve it, I will get e to the power of x square y on the left hand side is equal to x plus some constant. They have given an initial condition y of 0 is equal to 1. So y of 0 is, when I put y is equal to y of 0, I get the value of c, that is equal to 1. So finally I will get e to the power of x square into y is equal to x plus 1. This is the solution. So according to my solution, this will be the answer, 1 plus x e to the power of minus x square. Now coming to the previous one, Gauss seidel method is for linear algebraic equation. Gauss seidel method, linear algebraic equation, P4. P4, option D is the answer. Forward 1, yeah. Option D is the answer. Now question number 3, let x denotes the real number. Okay, find out the incorrect statement. Now s equal to 3 greater than, okay, x such that x is greater than 3 represents set of all real number greater than 3. So incorrect we have to find. This is correct one. X square less than is an empty set, absolutely correct, because x square is always a positive number. X belongs to A and x belongs to B. You see, and represents the union of set A. Wrong, this is wrong. Okay, why? Because and is generally symbolized by intersection, or is generally symbolized by and. Okay, so option 3 will be the incorrect statement according to. Okay, so union is generally defined by intersection, not, it should be defined by or. X belongs to A or x belongs to B represents the union of set A, not and. And is generally represented by intersection. Question number 4. A box contains 20 defective items and 80 non-defective items. If 2 items are selected in random without replacement, what is the probability that both items are defective? Now you see, let us take, there I think a box contains 20 defective, 80 non-defective. That means there are 100 altogether, 100 items are there. 20 defective and undefective are 80. Let me write it. Undefective are 80. Okay, undefective are 80. Now, if 2 items are selected at a random, so if 2 items are selected at a random without replacement, what is the probability that both items are defective? So 20 items are defective. Okay, so if 2 items are selected at a random without replacement, what is the probability that both items are defective? Okay, so when I choose the first item, I want it to be, so that means both has to be defective, right? That means there are 20 defective by default. There are 20 defective. That means the probability of getting defective in the first choosing, it is this. Probability of being defective in the consecutively in the second choosing is 19 by 99. That is equal to, if I solve it, I will be getting, this is 5 and I will be getting 19 divided by 495 is the answer. Question number 5. Question number 5, it is 19 by 4 is 19 by 495. For a circular shaft of diameter d, torque T, the maximum value of shear stress, I think we have done it a lot of time. It is generally 16 T by pi d cube, and this is the proof. I think T by J is equal to 2, that is tau by r can be written as d by 2, and if you solve it you will get the answer 16 T by pi d cube. This is a standard formula, you can remember also. Question number 6. A 4-bar linkage at the toggle position, the value of mechanical advantage. If you have observed carefully in my previous question, the same thing has been asked in the previous question paper also, when we calculate based on the omega output is keeping omega output is equal to 0. So this can be easily used. Toggle position is a position when our input and the output link are in a straight line. Okay, either 0 degree or their velocity is 0 at that instant. That is nothing but the toggle points. So toggle points means the output will be 0. When output will be 0, mechanical advantage is equal to infinity. Okay, so toggle points are the points where the output link is equal to the velocity of the output link is 0. This is just, we can say, the corollary of the previous problems that we have solved previously related to the mechanical advantage. You can just cross verify. Okay. Question number 7. It's a beautiful question. Actually, it may look like a vibration question, but actually it is a mechanics question. The differential equation governing the vibration system is. So whenever you see such questions, you have to find the differential equation of motion, right? So for that, the generic equation motion containing a spring, a damper and a mass is mx double dot plus cx dot plus kx is equal to 0. Okay, but here there is some scenario, they have they had made some slightly change. That means here they are giving some initial displacement as y, here they are giving some initial displacement x. So what we will do, we will take each and every system, spring, mass and damper. Let us take damper first. Okay, so if I observe the damper, so I see here that it is in this direction, in the damper. That means I am considering only this part, then again I will consider only this part, then again I will consider only this part. So you see here the damper is going in this direction, x direction, again it is going in y direction. So what is the what is the force that is acting on resultant force acting on damper? It is c x dot minus y dot. Why x dot minus y dot, y dot minus x dot? You see the entire system is going in x direction, in this direction only, in this direction only. That is why I intentionally took x dot minus y dot. Now coming to the mass, you see, when I give a small displacement in this direction, there is a equal and opposite force that is called inertia that is acting in opposite direction. Okay, got it? So if I evaluate properly, this is the proper definition of mass. Okay, here you will see, if I give a small displacement, the inertia is acting backward. So where actually the inertia acting? Inertia is acting, if you give a small displacement here, the spring force is trying to push the mass in this direction. The damper is trying to come to its original configuration. Therefore, in the mass you will find the damper force is acting in this direction. Okay, so spring force is pushing the mass in this direction, then the damper is retrieving its original configuration in this, therefore the force is in this direction. And since we are giving the displacement in this direction, our inertia is acting in opposite direction. So inertia, damping force and spring force are in same direction. So just put it, mx double dot, this is inertia force, this is damping force, and this is spring force, which are acting in same direction. So we'll simply add up, that's it. So the equation of motion is mx double dot plus cx dot minus y dot. It is not y double dot, it is y dot. Okay, plus kx is equal to 0. So the answer will be mx double dot plus cx dot y dot plus kx is equal to 0. This is the answer. Now question number 8. For a pin joint, for a pin-ended column length L, modulus of elasticity is second moment of inertia and the cross-sectional area I is loaded eccentrically by a compressive load P. The critical buckling PR is given by. So basically what they have asked is for pin-ended. So when we say pin-ended, we generally, so basically first we say what actually, so the buckling load. Buckling load is the load at which the, suppose this is my column, okay, and it is axially it is acting with some force. Okay, rather there is some supports, there is some support here, say pin joint or any other support. There are many types of support here. So the amount of load that can be acted on this point, so that this shape becomes this is called buckling. This is the minimum amount of force that is required to buckle it. Okay, so when there is pin support, the effective length, so the formula for this is pi square ei by L square, and L is different for different loading conditions. So when you take it is fixed free, the L will become 2L. When you took so here they have asked about two pin ended, that means a pin ended column. So when you talk about pin ended column, our L become equal to LE. When L become LE, just replace L by LE, and this is the answer, pi square EI by LE square, or rather L square. So pi square EI by option D is the correct answer. Question number 9. The number of inversions of a slider crank mechanism. So the number of inversions will be equal to the number of links that it has. For a slider crank mechanism, there are 4 links, so there will be 4 inversions. Question number 10. For a Newtonian fluid, shear stress is directly proportional to rate of shear strain. Okay, just remember this is not shear strain, this is rate of shear strain, that is rate of change of velocity with respect to the displacement. Okay, so it is rate of shear strain, just remember it, rate of shear strain proportional to rate of shear strain proportional to. Okay, now question number 11. In two-dimensional velocity field and velocity u and v along with x and y direction respectively, the convective acceleration along the x direction is given by. So convective acceleration, basically in acceleration there are the acceleration of fluid, there are two types of acceleration. First, convective acceleration. Second, local acceleration. Convective acceleration given, suppose in x direction, any direction, say x direction, so u is a component of that velocity in that x direction. So u into del u by del x plus v into del u by del y plus w into del u by del z plus del u by del t. So del u by del t represents the local acceleration and these represent the convective acceleration. They have mentioned the two-dimensional velocity. So what I will take in x and y direction, the options are there. So I will replace this with 0 and the convective acceleration, so local acceleration will be also 0. So it will be u into del u by del x plus v into del u by del y. So option A is the correct answer. U into del u by del x plus v into del u by del y. Question number 12. The dew point temperature is the temperature at which condensation begins when the air is cooled at constant, it is pressure. Okay. So you observe it carefully. This is the TS diagram and dew point means what? Suppose this is where this is where this line represents the constant pressure points. Okay, so dew points comes into picture when my gas will try to my vapor will try to convert into water droplets. Okay, so when it happens generally at a saturation point. Okay, so this so everything is the thing that remains constant and in entirely is the pressure only, pressure. Okay, so the condensation begins when the air is cooled at a constant pressure. So here the flow of the diagram will be in this direction. Okay, so here entirely pressure remains constant and there is a chart called psychometry chart. In the psychometry chart is entirely based on constant pressure. Okay, you will find the pressure is constant, that is they have taken atmospheric pressure, that is 1.01325 bar as the standard pressure and the entire psychometry chart has been made at a constant pressure. So answer will be here the answer will be pressure. Question number 13. In a composite slab, the temperature at the interface T interface, here is the interface between the two material equal is equal to average of the temperature of the two end. Okay, that means T interval is equal to T1 plus T2 by 2. Assuming that the steady, remember this is steady one-dimensional heat conduction, which of the following statement with respect to the thermal conductivity? So we need to establish the relation between K1 and K2 based on the relation of T1 and T2 given here. So they have mentioned a word called steady one-dimensional heat conduction. So steady one-dimensional heat conduction matlab the heat that has been transferring from this here is equal to the heat transferring here is equal to the heat transferring at the interface. That means suppose I take Q flux, that is the heat flux here is equal to heat flux here. So that means T1 minus T interface by 2B. I think they have given the width 2B and B here. So 2B by K1. This is the thermal resistance. Okay. You might be knowing, right, the electrical analogy between the heat conduction and electricity. So here the delta T acts as a voltage. Q, the heat flux, acts as a current and thermal resistance is equivalent to the electrical resistance. All the operations of the electrical resistance also applied on the thermal resistance. So it means in terms of parallel and series connection. So we will simply provide this is the thermal resistance for the first thickness of the bar. Then the second heat transfer resistance. Sorry, the thermal resistance for the second thickness will be B by K2. Okay, if I simplify it, we can see that the K1 is equal to 2K2 is our answer. You need to simplify it, okay, to get it. So the relation is K1 is equal to 2K2, option D. Now question number 14. Now I told you that in a previous day I told you that I will be explaining you regarding the turbines, because for the GATE 2021 which we are appearing for, they have intentionally added the concept of turbines. So we need to work on to get to fetch good marks. So anyways, we will try now. Now you see here, I have explained here. I think this is called for the Pelton turbine I have used. Okay. Now you see the Pelton turbine is in this form. Okay, this is the complete bucket of the Pelton turbine. This is the complete bucket of Pelton turbine. Now here V1 is the absolute velocity of the jet of water. Absolute velocity means there is no, it is not with respect to anything. It is the absolute velocity of jet that is approaching. V1 is the vane velocity. Vane velocity means the velocity with which the blade is moving, the bucket is moving. Okay. So this is the vane velocity. Now definitely when two bodies are moving, therefore there will be a relative velocity. So the VR1 is the relative velocity. Okay, so U1 is the vane velocity, because vane velocity will be less as compared to the jet velocity, because jet velocity has to be very high. Okay, so V1 is the jet velocity, U1 is the vane or the bucket velocity. Therefore because of this velocity difference, there acquires a relative velocity. Okay, this is the splitter means it splashes the water, distributes the water in two different ways. Okay, so VR1 is capital V1 minus small u1. So VR1. So if there is no head loss, there is no friction acting on the blade. So VR1, that is relative velocity of R1, is equal to relative velocity of R2. Okay. So if there is no head loss there. Remember, I'm not explaining this particular question number 14. I will come to it later on. But before that, I want to explain how the mechanism, how the numericals of the blade comes into picture. Now, VW2 is the horizontal component of the absolute outlet velocity, VW2. So, once the water splashes here, so water goes here. If there is, as I said, that there is no change in the magnitude of relative velocity, because there is no such head loss. Okay, so the relative velocity will be in this direction, the direction of the blade. Okay, now we know that u2 means the blade is moving in the same direction, so u1 will be equal to u2. You will make this one. Okay, so correspondingly we can find the value of v2, because v2 the vector, because of the vector addition or subtraction, we can find vr2 direction is here. We know that vr2 direction is here, u2 direction is already here, and from here we can find the vr2 direction. Okay, so sorry, v2 direction. V2 means the absolute velocity of the jet at the outlet. Okay, now the absolute velocity of the jet has two components, vf2. Whenever you see vf2 is actually the flow velocity. Okay, the it means the velocity, the vertical component of the absolute velocity of jet at outlet, and whirl velocity vw2. Whirl velocity is actually the horizontal component of the absolute velocity of jet at outlet. Okay, you will find here also vw. You won't find here vw1. Why? Because vw1 is equal to the v1 only. This will be equal to v1. Okay, because it is not getting means it is not making some angle with respect to horizontal. So horizontal component of the absolute velocity of the jet is whirl velocity. Vertical component is called flow velocity. Okay, now, so I have already explained VW2 is the horizontal component of the absolute velocity of the jet, and VF2 is the vertical component of the absolute outlet velocity. U2 is equal to U1 minus velocity of plane. Velocity of the okay, U1 is equal to, U1 is equal to U2 is nothing but the velocity of plane that I have explained you. Now alpha beta, these are alpha, there you can see alpha and beta angles. I think, you will find alpha and you will find beta. Now what are the alpha? These are guide plane angle at the inlet and outlet. So this alpha that you find here, you can say alpha and beta are the velocity of the velocity of the absolute velocity of the jet at inlet and outlet with respect to their whirl velocity. So here you will find beta and here you will find alpha. So alpha, since the whirl velocity and the absolute velocity of the jet is coincident here or horizontal here, so the it will be 0 degree. Alpha will be 0 degree. Similarly here it is non-zero. Absolute velocity of the jet and the horizontal or the horizontal component of the velocity, absolute velocity is non-zero, so it will be given a term beta. Now what is phi and theta? So phi and theta are the blade angle velocity at the inlet, blade angle at the inlet and outlet. Okay, so blade angle with respect to inlet and outlet. Okay, that means phi or theta represents the relative velocity, it is the angle between the relative velocity of the jet with respect to the motion of bucket. So u2 is actually the bucket velocity, which is same as u1. Okay, now vr2 is the relative velocity of the jet at the outlet. So here you will find an angle called phi. Similarly, here if you see, u1 is nothing but my bucket velocity, and with respect to what? With respect to jet is u1, and these two are coincident. So I'm sorry, with respect to vr1, which is coincident, therefore coincident, which says that it is 0 degree, therefore theta here is equal to 0 degree, and phi is some non-zero angle, because it is the relative velocity with respect to the bucket vane angle is making some angle, okay, so which is non-zero. Therefore we see the angles are alpha beta are the guide blade angle at the inlet and outlet, and phi and theta are the vane blade angles at the inlet and outlet, okay. So this is the representation. This is my absolute velocity of the jet, and which has been broken into two parts: wall velocity, which is horizontal component; vertical velocity, which is the flow component. Now the guide blade angle, so it is between the absolute velocity and the flow velocity. Vane angle is the angle between the relative velocity and the flow velocity. It's not flow velocity, I'm sorry. You can call it as a jet. It's vane velocity, not flow velocity, it is vane velocity, okay. Now formula for the Pelton turbine, you see Fx, what is force acting in a x direction, is equal to rho a v1, that is nothing but your mass, okay. Rho a v1, that is initially how much mass it is striking, whole into vw1. Why vw1? Because jet is also moving and bucket is also moving, so there is some sort of relative motion that is going on, okay. So vw1, that is this one, plus or minus vw2. Here you will find vw2. Now when we come across vw plus or minus, and so plus comes into picture when alpha 2, that is this one alpha 2 is less than 90 degree, and when alpha 2 is greater than 90 degree, it is minus, okay. Okay, horizontal absolute velocity. Okay, so Fx is equal to rho a v1. This is nothing but the mass that we are force is nothing but the change in impulse, so that's the same formula that has been applied here. Rho a v1 is the mass that we are entering right now, impinged right now. vw1 plus minus vw2. So when alpha is less than 90 degree, it is come under plus, and when alpha is greater than 90 degree, it comes under minus. So where is alpha? This blade guide blade angle is nothing but alpha. So you see here alpha and beta. So these are the things that we come across, okay. Now what is work done? Work done is equal to the force that we calculate first, exerted by the jet into the velocity. Just multiply it with the initial velocity of the jet. Now kinetic energy is equal to half m v1 square. Half m v1 square means, so the kinetic is a half, this is the jet mass of the jet into v1, that is it is executing. Half mv1 square means this is the mass of the jet that is impinged, and this is v1 square. Now what is v1 square? I have already told you, absolute velocity of the jet of the water. Now hydraulic efficiency, work done divided by kinetic energy. What is the work done? This is the work done, rho a v1 into v whirl 1 plus minus whirl 2 into u divided by half a v1 cube. So from here you get the answer as this is the hydraulic efficiency. No need to remember it, just understand the concept and put based on the question that they have asked, okay. So don't need to remember each and everything. So vw2, you can calculate the vw2 based on the diagram that you made. So vw2 is equal to either vr1 cos phi minus u2, or we can say v2 cos beta. So it's the same thing that we have done here. There is no need to remember, okay. There is no need to remember. You just understand this particular diagram, understand these particular terms. Based on that, you just identify how the force is calculated, the change in momentum. From here, how you calculate the work done, and then how the kinetic energy of jet. The kinetic energy of jet basically deals with the initial kinetic energy that you are giving. That is why you are calculating the hydraulic efficiency. That means energy that you have provided and the work that it is being done, okay. So the maximum efficiency, just differentiate this with respect to a velocity v1, which is because v1 is the only parameter which is variable here. So we'll find that the we get the maximum efficiency when our blade velocity will be half the jet velocity, because at every point of time jet velocity will be way higher than the blade velocity. So for in order to attain the highest velocity, blade velocity should be half that of jet velocity. Okay. Now coming to my question here. In a Pelton turbine, the bucket peripheral speed is 10. That is, I think we have generally nominated as V1. I think, yeah, V1 is equal to V1 is equal to 10 meter per second. Now, the water jet velocity is 25. U1. This is whirl. Okay. This is what the means of whirl is the horizontal component of the absolute velocity of the jet. Here whirl that I have mentioned here as u in my explanation is u is equal to v1. Why? It is actually striking horizontally, so u will be equal to whirl1. Now the jet water jet velocity, the volumetric flow rate is 0.1 meter per second square. Okay, so from here what all things we can carry out, we will see. If the jet deflection angle is 120, now I have mentioned I think I have given here jet deflection angle. You see here the deflection angle will be with the axis, right? With respect to the axis, this is the angle of deflection. Okay, I forgot to explain you, this is the angle of deflection. So with respect to horizontal, what is the direction of vr2 is nothing but our angle of deflection. So this angle of deflection is 120 degree. The flow in the flow is ideal, that means there is no friction, no head losses, nothing. Now the flow developed is the power, sorry, this is power, the power developed, because the units are in kilowatt. So what we will do, first the power, that is nothing but the work done per unit time, it is similar to the work done. So how you will develop, we know that rho q is nothing but our mass. Okay, they used to do rho av, but since they have already given 0.1 meter cube per second, that means mass per units time, I got it. So vw1 plus vw2 into u is our power developed. So now what is now the challenge is to calculate the corresponding vw1 vw2. Now we will make it, since there is no head loss, this is the weight, this is the direction of the vane. I will draw a corresponding arrow here. Now the v2, this will be the corresponding v2, this will be the corresponding v2, that is absolute velocity of the flow. Okay, now this will be the flow, this will be the flow velocity, and this will be the whirl component, flow component and whirl component of that absolute velocity of the jet. This is the relative velocity of the jet. This is the bucket speed. Now I need to calculate vw2. Vw2 I can calculate, how we will calculate vr2, that has they have given, right? Okay, I think velocity 15 meter per second. No, they have not given. No. I think we have already calculated. So they have given the velocity of the jet, that is 10 meter per second. vw1, that is whirl velocity, we know it is that of same as that of jet, that is 25. Now we can calculate vr1 also. Okay, the relative velocity of the jet with respect to the bucket. We know that there is no head loss, there is no friction acting, so this vr will be same. So vr2 is same as 15 as here. From here we calculate the corresponding, we know that u2, we can get the corresponding value of, I think this is I given here, the angle is 5. Okay, now once I calculate it, we can get the corresponding value of v2 also. Okay, so from here what is our intention? My intention is to calculate the vw2. Okay, so vw2 can be called as vr2, means vr2 cos phi minus this 10. So this is the same. From here, if it is given 120 degree, so this is 60 degree, and since these are parallel lines, so this can be also claimed to be 60 degree. Otherwise we can calculate the angle between v cos, no, we cannot do that, I'm sorry, we cannot do that. We from the deflection, the jet deflection angle, from the jet deflection angle itself, we can calculate the this angle, this angle, the jet deflection angle. So the 180 degree, 180 minus 120 is 60 degree, and 60 degree, since these are parallel lines, so this will be 60 degree again. This will be a 60 degree again. Okay, so what will be work velocity, which is responsible for calculating power? It will be VR2 cos 60 degree minus this 10. So VR2 cos 60 degree minus 10. It is left with minus 2.5 meter per second. Okay, so this is the velocity that we got. Now the power will be this is mass per second into 25 is my wall velocity, initial wall velocity, minus of 25 per second. Since alpha is greater less than 90 degree, so this will be plus v1, as I have mentioned here. This is plus vw2. Okay, so this alpha value is coming less than 90 degree, so it is plus vw2. So plus of minus 2.5 is equal to minus 2.5, and that is equal to 22.5 kilowatt. 22.5 kilowatt. So answer is 22.5 kilowatt. So I hope you understand the mechanism, means how I derived the formula and how I applied the formula here. Okay, so the question that they may ask this year, that is for GATE 2021, they may be asking somewhere related to it. So you don't have to you just need to see these questions and practice. I would suggest you to look the book called Subramanya, and solve all the questions of the solve all the questions of Subramanya, so that you can get an idea how the questions they can ask. Okay, because there are nearly 40 questions, 40 to 45 questions on the hydraulic turbines. You just solve it and you will get all the entire scenarios that they can ask. Okay, so question number 15. The expandable pattern is generally used for investment casting. Question 16, spheroidizing. What is spheroidizing? The main purpose of spheroidizing treatment is to improve. So it is actually, spheroidizing is produces a rounded or globular form of carbides. Okay, so basically that it has a very fine surface finish and produces because of the carbon globules, the globular form of carbide. Now high carbon steel are spheroidized to improve machinability, especially in a continuous cutting operation. So it improve machinability, right? Machinability of a high carbon steel. So it used to improve machinability of high carbon steel. So this is the basic some extra knowledge about the spheroidizing. Now question number 17, NC contouring is an example of. Now if you observe it in the previous year, I think GATE 2004 or 2005, they have asked regarding they have given few examples. They have given few operations like milling, drilling, arc welding, spot welding, and we have to identify which of them is a continuous process, continuous NC process. Now they have reverted that question and they have given NC contouring process is an example of. It is an example of. So NC contouring, what is actually a contouring? Suppose this is my workpiece, initial workpiece. Now I will using a tool, I will operate in such a way that I will get a final product as this one. That means I will remove these particular portions. That means this particular stud is present here, but this particular portions roundabout is removed. Okay, so this is called contouring operation. There is another called pocketing operation. These operations are basically very common in CNC machines. If you take a course of it, then you will get to know. Pocketing means I will pocket it. That means I will make a hole. This portion completely remains. Rather, I remove it. I make a copy of this. Let me make a blind copy. So I'm making a blind copy of this workpiece because the same workpiece will be operated. Okay. So what I will be doing here is in pocketing operation, I will make a hole or any other. So what I will be dig it. Okay. So this is pocket. This is called pocketing operation. That means basically the hole is not visible in machining. Okay, we can call it as one of the pocketing operations. Okay, so it will surrounded by something and we will pocket it. Or um, yeah, this is one such example of a pocketing operation. This is pocketing operation. So this is a contouring operation where with respect to one structure we are eliminating other structure. Now in pocketing operation, with respect to other structure we are eliminating a specific one. This is called pocketing operation. Now they are asking about contouring operation. In this contouring operation, what we need to do, it is a continuous path, sorry, it is continuous path positioning process. Why? Because each and every time I will be allocating a path. That means first they will be removing this portion, then they will be removing this portion, then they will be removing, similarly they will be removing subsequent portion layer by layer. Okay, means first this layer, then this layer, and also, so it's a continuous path positioning process. So this is how I so from here we found that how things are correlated with respect to the previous year. So previous year they used to ask the question based on which are the process which are continuous process. Now they have asked that yes, we are NC contouring process is what type of which of the following options is what type of NC contouring process. So for that the important concept is you should know what is contouring and what is pocketing. I have already told you these things. You will get to know when you will be working in a mechanical shop, specifically in CNC mechanical shop. These terms will come across. Okay, now let us see question number 18. A ring gauge is used to, it is used to measure the shaft. Okay, it is used to measure the shaft. So outside diameter but not roundness, roundness but not diameter, both outside diameter and roundness. So first of all, these threads we generally don't use to measure the threads. Okay, okay, so ring gauge, it's gauge actually, not gauge. So we only measure whether our diameter are satisfying the limits or not. So we are not checking roundness. So it is called, we used to measure outer diameter but not roundness. Okay, for roundness we generally use, in order to measure the roundness we generally use um, there is something called, there is a stylus or something. I could not recall that particular name. We generally use to measure the, basically this comes under the geometrical tolerance. The term that is something related to the in order to measure the in order to measure the roundness or the physical structure, we generally comes under geometrical tolerance. And there is a stylus which we generally keep and measure the round, dial gauge. It is called dial gauge. Okay, dial gauge is generally used to measure the roundness of the shaft, or we can say the linearity of the surface also. In a literal sense, we use a term called dial gauge. So dial gauge is generally used to measure roundness, but ring gauge is generally we are focusing on the outer diameter. Okay, whether it is going inside or not, inside that particular gauge or not. Okay, now question number 19. The number of customer, this is actually a queuing problem. In the previous year 2005, I have already given you the entire problems or formula that will be used for queuing theory. Just look at it and you will get to know how this question has been solved. This is just put the formula and get the answer type of question. A number of customers arriving at a railway station reservation counter is in Poisson's distribution, and arrival rate is 8 customers per hour. Okay, so lambda is 8, and what is mu? That is service. The reservation clerk counter takes 6 minutes per customer. So this is 8 per hour, this is 6 minutes per customer. That means it is servicing at the rate of 10 customers per hour. Okay, now on an average with exponentially. So whenever you see this queuing theory, it is actually the arrival is in a Poisson form, and service is in exponential. So arrival is comes under Poisson's distribution, and service will be exponential distribution. Exponential distribution. So this is arrival, this is service. Okay, this is service provider, we can say. So the average number of customers in the queue, remember this I described previously, that what is the difference between queue and a system. Queue means when somebody is that means the number of persons who are in the queue who are waiting but they are not being served yet. System means along with all the people who are waiting, the one who is actually being served. Okay, or the number, it depends upon number of stations. If there are n number of stations, so n number of people who are being served plus the n into the number of queues that is executing right at that point of time. But the system includes the person who is being served as well as the queue who is waiting. So here they have asked about queue, that means only the people who are waiting. So for that means the length of the queue that we need to find out, that is given by row square divided by 1 minus row. Now what is row? Row we generally calculate by lambda by mu. Always remember this service rate that or utilization factor will always less than 1. That means 8 by 10, if you divide it, you get something less than 1, that is nothing but row, that is utilization rate. So row square divided by 1 minus row, if you solve it, you will get the value of 3.2. If you want to get what is the length of system, you just use this formula. Length of queue is equal to row into ls. So from there you can get the value of length of system, but that's not required. So the answer is 3.2. Question number 20. In a MRP system, material resource planning, component demand is. So the MRP system includes MPS, that is MPS, I think material price schedule, then bill of material BOM and inventory records. Okay, so the component demands what? So the MRP, the component demand is calculated by the MRP system from the master production. It is, I'm sorry, it is MPS's master production schedule. It is master production schedule. I'm sorry, master production schedule, bill of material and inventory records. Okay, if you see it properly, the component demand is forecasted, no, established from the master production schedule, calculated by MRP system from the master production schedule. Okay, so the correct answer would be C, option C. Question number 21. It's a simple one. We have to find what is the eigenvalue for the matrix x square is equal to ss. Okay, so it's basically depends upon there is a property of eigenvalue. Suppose A is a matrix whose eigenvalue is alpha and beta. If we multiply A with A, that is A square, for that the eigenvalue becomes square of the its own square. So therefore, if 5 1 is the eigenvalue, then their square will be 125 or 25 1. Answer will be this much, 1 and 25. Question number 22. There is a line normal to the function. It's very simple. It's coded geometry question. The function they have given x minus 8 to the power 2 by 3 plus 1 at p02. So first we'll find the slope of this f of x. Once we find the slope, we will at 0.5. So the slope at 0.5 will be minus 1 by 3. Now we have to find the normal to the function, right? Normal has normal. That means we know that normal is equal to rather we can say if two lines are perpendicular to each other. Suppose this has a slope m and this has a slope n. So m into n is equal to minus 1. That means m is equal to minus 1 by n. So this has a slope 1 by 3. So normal to it, the slope of the normal will be minus of 1 divided by 1 by 3, that is equal to 3. Now the equation will be, now since it is also passing through point 0.5, since it is passing through the point 0.5, y minus 5 is equal to, this is the slope, x minus 0. So the equation of the line will be y minus 3x is equal to 5. Y minus 3x is equal to 5, that is equal to y is equal to 3x plus 5. Option B. Question number 23. Assuming I is equal to square root of minus 1, t is the real number, integration 0 to pi by 3 e to the power of I t dt. So this can be solved in many ways actually. You can use the Euler formula to expand it and so then also you can do, or you can directly solve it from this way. But anyways, what I will be doing is I will first expand it in a Euler formula. Minus I, that means e to the power of I pi by 3 can be written as cos pi by 3 plus I sin pi by 3 minus 1. Then I minus I, and this in an expanded form. So what I did is initially I integrated it. Okay, whatever solution I got it, I expanded it. I expanded the Euler formula there, and once I got it, I got the answer as root 3 by 2 plus I by 2. Root 3 by 2 plus I by 2. Question number 24. See, it's very simple. Just apply the L'Hospital rule. Right now, if you observe it, L'Hospital rule is only applicable when you get. L'Hospital rule, I'm sorry, let me repeat once again. Question number 24. L'Hospital is only used when you will get the solution in the form of 0 by 0 if you put the limits. But if you put the limits, x tends to 3. Am I getting anything 0 by 0 form? If I put it, you will get limit x tends to 3, that is equal to 3 19 18 minus 7 21 plus 3 divided by 5 into 9 5 into 9 45 minus 5 9 into 5, then minus 12 minus 3 36 minus 9. The denominator is 0, numerator is also 0. Yes, we are getting 0 by 0 form. Then we will apply L'Hospital rule. Otherwise, we will not. So applying L'Hospital rule means applying L'Hospital rule means differentiating the numerator with respect to a variable, differentiating denominator with respect to a variable, and then applying the limits. So differentiated it with respect to the numerator with respect to x, and then denominator with respect to x, and then put the value of x. We got 12 minus 7, 30 minus 12, that is equal to 5 by 18. So 5 by 18 is our answer. So question number 25. It's match the following. Singular matrix is the matrix, is actually a definition. It's a definition based question. Singular matrix is a matrix whose determinant is 0. Non-square matrix, eigenvalue is not defined because eigenvalue is always defined on a square matrix. Real symmetric matrix will have real eigenvalues, and orthogonal matrix are those matrix whose inverse is equal to its transpose. That means A into A transpose is equal to identity matrix. Also, its determinant also equal to 1. Now, if I check it, singular matrix is equal to A P3. P3, okay, option A, C, D. Non-square matrix, eigenvalue is not defined. Eigenvalue is not defined. 5. Non-square matrix not defined, eigenvalue not defined. 5. I think they have not mentioned this. Real matrix, eigenvalue always real. R is 4. A determinant. Okay. So in non-square matrix also determinant is not defined. That is also correct. And eigenvalue is also not defined. So I think option A will be correct. And if I evaluate, I can also write determinant is also not defined on is not defined. Okay, determinant is not defined, eigenvalue is also not defined. Question number 26. dy by d square y by dx square plus 4 dy by dx plus 3 is equal to 3 e to the power of 2x. We have to find the particular integral. It's a very beautiful question because this is not basically a solution of a differential equation contain two parts, general solution and particular solution. So whatever we do in the left hand side to solve the left hand side to get the general solution, but when the RHS is not equal to 0, then we have to find the particular solution also. So for particular integral, what we need to do, there is a simple formula. You just write it in this form: d square plus 4d plus 3, where d represents dy by dx of y is equal to 3 e to the power of 2x. So particular integral for this will be, just remember this, there are many methods. One method is this one. For this particular scenario, this is particular integral will be 3 e to the power of 2x divided by d plus 1, and this is nothing but the contracted form, d plus 1 into d plus 3. In order to find the particular integral, substitute the value of d with the power of to the power of e. That is, the power of e is 2, right? So just substitute it in the value of d. So you will get 3 e to the power of 2x divided by 2 plus 1 into 2 plus 5. So from here get e to the power of 2x divided by 5. Answer will be e to the power of 2x divided by 5. This is the answer. Okay. Now question 27. The multiplication matrix E and F is G. If I multiply E with F is G. Okay. That means F is equal to G into E inverse. Okay. I don't know whether I have given any shortcut method for the inverse or not. But okay. I will be giving you the shortcut way to find the inverse. Okay. So yeah, do one thing, just observe this particular. So basically what we need to find, we need to find the inverse of E, right? So what we will do is you just concentrate on the you just concentrate on this particular matrix. You start with cos theta. Okay, this 2 2, you write 2 2 here. In a whatever you are going to write now, you should be writing in you will writing in a vertical way. You will writing in a vertical way. Cos theta, then 0, then come here sin theta, and then write cos theta. You complete one loop. Okay. Then go downward. Start with 0, 0, then 1, then again 0, then 0, 0, 1, 0, 0. Again go to upward, minus sin theta, 0, cos theta, and then minus sin theta. Sin theta 0, cos theta, minus sin theta. Again back to the second row, cos theta 0, sin theta, cos theta. Now what you will do, you just multiply these things and get one answer. That is, here it will cos theta, put it here, put it here. Here you will get how much? It will be plus sin theta. Here we will be getting 0. Then here you multiply, here you multiply, you will get minus sin theta, minus sin theta. Here you will get cos theta. Here you will get 0. Again you will multiply 0, 0, 1. So this is the inverse. Okay, so this is the inverse of this one. I hope you got this. E inverse, this is the shortcut method to find the value of inverse. Okay, and talking about the determinant, I think the determinant is 1 only. Okay, the determinant is 1, so we can divide by the determinant as 1, so there is no such big deal. So this is the shortcut method to find the determinant. So I hope you understand it and you can imply it so that you can save the time. So, and now this is a simple determinant multiplication, and once you multiply the determinant, I think this is the identity matrix, right? Identity matrix multiplied by any matrix is the matrix itself. Therefore the answer for this will be cos theta plus sin theta, cos theta plus sin theta, minus sin theta, cos theta. This will be my answer. Option C is the answer. Okay. Question number 28. Question number 28. Consider the continuous random variable with the probability distribution function f of t is equal to 1 plus t for minus 1, t lying between minus 1 to 0, and 1 minus t for t lying between 0 and 1. Just wait. So we have to find the standard deviation of the random variable. Okay. So standard deviation of the random, for that what we need to find first the mean. Okay, this is the function. Basically this is a continuous function, and using the continuous function formulas you need to find the mean and the variance. So first we calculate the mean, and variance is the deviation from the mean. So first mean is f of t integration from the limits to get the mean. So I will multiply t into, this is, I think the mean will be, the formula for the mean is x into f of x integration. Okay, and x minus x bar square f of t integration is the variance. Okay, so we have to find the standard deviation. Standard deviation is square root of the variation, so whatever value we'll get, but first we find the mean. So mean is t into 1 plus t integration minus 1 to 0 and t into 1 minus t 0 to 1. So if you solve here, you will get the mean value as 0. Now coming to the variance, that is sigma square. Standard deviation square is integration minus infinity to infinity t minus t bar, that is mean square f of t dt. So since it is ranging from minus 1 to 1, so we will integrate those values from minus 1 to 0 and 0 to 1. So t minus 0 square 1 plus t and t minus 0 square 1 minus t. So I will get the variance. So once I get the variance, I will get the variance as 1 by 6. Okay, this simple integration, there is no such mathematics involved. Simple integration. Once the you get the variance, standard deviation is the square root of variance, that is equal to 1 by 6. So answer will be square root of 1 by 6 or 1 by square root of 6. Okay, now question number 29. No, I think question number 29 intentionally skipped it. Okay, where the addendum is used? Addendum is actually used in gears. Instantaneous center velocity, I think this term are used with linkages. Section modulus, we generally deal with beam while calculating the bending stress. Remember this section modulus is given by I by y. In the previous question, one of the questions they asked that ratio between moment of inertia, second moment of inertia and section modulus. This is I by y. Okay, I will discuss this later on. However, prime circle is related to cam. So S1 A4 P4 S1 P4 S1, option A or option B. Instantaneous center is 4, that means Q3. So option B is the correct answer. 4 3 2 1. Now question number 13. So here in this I will be proving how I derive the formula for friction disc. Let us see. A disc clutch is required to transmit 5 kilowatt at 2000 rpm. Okay, this is the power, or rather transmit 5 kilowatt at 2000 rpm. The disc has a friction lining coefficient of equal to 0.25. Bore radius of the friction lining is equal to 25 mm, assuming uniform constant pressure of 1 megapascal. Since they have already mentioned this is a constant pressure, applying this wheel is applying a constant pressure, so it is 1 MPa. If they had not mentioned anything, we will assume that it's a constant wear. But if they have mentioned constant pressure, so we will say that it is if they have mentioned, so we will work accordingly. Basically the discs are operated on two different scenarios: constant pressure and constant wear. When our disc is new, when we have very recently installed our brakes in our system, in a vehicle, there is no friction between the friction lining and the brake surface, the wheel surface, due to which there is no wear and tear in the brake. So the pressure that will be applied for a newly braked system is a uniform pressure. But as long as our brake wears out, it wears out in a uniform fashion. So we apply a theory of uniform wear theory. We will see later on, but this question is related to the constant pressure. Okay, so before going to it, you see here what are the calculations involved. I will first focus here. For a uniform pressure, what is uniform pressure? Pressure is nothing but work divided by load. This is load that we are applying divided by area. So area is pi into radius, outer radius of the clutch disc minus inner radius of the disc square and all. Torque is nothing but your the friction into radius. Okay, so what is this friction? Where is this friction coming out? This friction is nothing but the pressure into the area, 2 pi r into dr multiplied by r. Okay, so if I if I show, it is mu friction coefficient, force P into 2 pi r into dr into r. Okay, this is the torque. From here it is coming, because this is the frictional torque, frictional force, and this is the radius multiplied by the radius, and we are integrating from r1 to r2. This torque, finally we get the torque is equal to this much, 2 by 3 pi p mu r2 cube minus r1 cube. Okay, so the pressure they have already given 1 megapascal. So from the so this is the power. Actually this is not we know that power is equal to 2 pi nt by 60. From here we calculated the torque. Okay, this is what we have calculated already from here. So this T is equal to 75 by pi Newton meter, and when we multiply by 1000, I got 75,000 Newton mm by pi. Okay, just put it here, just put it, just correlate this formula and all those values they have mentioned there. Okay, and you will get the outer radius, that is R2, that we need to calculate. I think they have given the inner radius, I think. Yes, the friction lining, the bore inner radius is 25 mm. So inner radius they have given. So from here we can calculate the corresponding value of R2. Okay, so this is the basic fundamental equation, the approach, why we approach to this, because I could have directly given this formula, but I think the understanding for the derivation of the formula is very important, because until unless you don't understand, mugging of this formula will not going to help you. Okay, you can derive this, it hardly takes 30 seconds to derive this particular formula. Okay, this is for uniform pressure. Okay, so I got the radius is equal to 39.41, so answer will be option A. Question 39, question 30, oh 30 question. Question number 31. 20-degree full depth involute profile, 19 tooth pinion and 37 tooth gear are in mesh. The modulus is 5. Center distance is very simple. The center distance is given by m into, just remember this formula, m into z1 plus z2 by 2. Okay, just put the formula and they get the answer. The answer is 140 mm. Now question number 32. Actually this involves the some calculations that this is called interpolation theory. Okay, that means the two endpoints have been given, we have to interpolate the intermediate value. So if you see question number 32, cylindrical shaft is subjected to alternating stress of 100 megapascal. Fatigue strength can be sustained to 1000 cycle is 490 megapascal. That means what I did is I took a log graph. Okay, now why log graph is taken? Because the values that you will find here is very high. It will generally 10 power of 6, 10 power of 3. So in order to encapsulate in a very small area, like if I take the log here, I got the value as 3 and 6, log 70, log 100, log 90, you will get a value which can be encapsulated, and the graph that we found is a linear graph. This is important, because whatever operations that we are doing, we are assuming this to be a perfect line. So the perfect line can be assumed by when we take a log graph. Okay, so we plot this graph. That means 1000 cycle at 490 megapascal. So 490 megapascal corresponding to 3, that is log of 1000 is 3. Then of 100 megapascal, the then corrected endurance strength is 70 megapascal. That means at 70 megapascal it reaches 10, that is 1 million cycles, that is 6, 10 power of 6. Okay, now I have to find at 100 megapascal what will be my cycle, what will be my number of cycles. Okay, so what I did is, at this point, what is your point? It is, I can say 3 log 10 490, here it is 6 log 10 70, here it will be something, say n, rather I took x, log 10 100. Okay, so that means if I take a straight line, the slope will be same. Okay, that means log 490 minus log 70 divided by 3 minus 6 minus 3, the slope is same as log 10 490 minus log 10 100 divided by 3 minus x. So we only need to calculate the value of x. Once I calculate the value of x, I know that This x is nothing but the log 10 of this life represented by L is equal to so and so. From here I get the value of L. So this L is equal to 281688. So approximately the answer is this one. You may not got the exact value, but you will get the value somewhere like this. Okay, 281688, 281917. Okay. Now question number 33. So whenever you come across these type of questions, especially in design, no, in to calculate these using interpolation, you take at least 4-digit decimal place. Okay, so that you can get a more accurate value, because you will get the cycles in terms of millions. Now question number 33. According to von Mises distortion energy, the distortion energy under the 3-dimensional stress state is represented by. So that is the change in the distortion energy is given by 1 plus mu divided by 6e whole into sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, plus sigma 3 minus sigma 1 whole square. If I evaluate it completely, I found it is 2 sigma 1 square plus 2 sigma 2 square plus 2 sigma 3 square minus 2 sigma 1 sigma 2 sigma 2 sigma 3 sigma 3 sigma 1. Okay, and when I took common 2 common, I left with 1 plus mu by 3e whole into sigma 1 plus, but this is the mother formula that you need to remember for distortion energy. You will get this. Okay, and distortion you need to remember distortion energy, because distortion energy is basically used for ductile materials, and more or less they used to ask this question regarding distortion, von Mises criteria. Now question number 34. A steel bar of 40 mm cross 40 mm square cross section is subjected to an axial compressive load of 200 Newton. If the length of the bar is 2 meter, E is equal to 200 GPa, the elongation of the bar. It's very simple, just put the formula. Delta is equal to PL by AE. So P, I think, given 200 kilonewton. So you have to convert each and every unit in terms of meter and Newton, so that you can get the value, whatever value you get. So E is equal to 200 GPa. Now GPa is 1 GPa is equal to 10 to the power of 9 in Newton per meter square, or we can say 10 to the power of 3 Newton per mm square. Question number 35. Question number 35, I think I am getting 1.25 answer. 1.25 is the answer. Now question number 35. If CF is the coefficient of speed of fluctuation of flywheel, then the ratio of omega max by omega minimum is. Now what is CF? CF is the coefficient of speed of fluctuation. It is the range divided by mean. Means it is the speed range divided by the speed mean. Okay. Now if you solve it properly, you will get an algebraic expression. Once you solve, you will evaluate in terms of omega max divided by omega min. That is equal to 2 plus CF divided by 2 minus CF. So 2 plus CF divided by 2 minus CF. Question number 36. The bar having a cross section of 700 mm square is subjected to axial load at a position indicated. The value of the stress in the segment QR. Okay, so what I will do, I will take a cross section and I will take the free body diagram. Here I found that looking at this question, I can easily find that the stress that is acting here is 63 minus 35 in tensile direction, because it is away from this, so it is actually elongating. Okay, so value of the stress, so 63 minus 35 divided by this cross sectional area. Remember, this is in mm square and you are getting in Newton, kilonewton. You have to convert each and every unit in terms of in a standard unit. So in a megapascal means Newton per mm square you need to convert, and you will get this 40 MPa is the answer. Question number 35. If a system is in equilibrium and the position of the system depends upon many independent variables, the principle of virtual work states that the partial derivative of its total energy with respect to each of the independent variable must be. So as we know, potential energy is actually the energy based on the configuration of each and every point in a system. So when we change the variable, okay, our potential energy also changes. Okay, but here they have given here that if the system is in equilibrium, that means that each and every point in the system is lying at a static point, it is not moving at all. Okay, so therefore, as we know, as I told you that potential energy is a function of individual variables, so potential energy at an equilibrium system is constant. So that means derivative of potential energy with respect to variable is 0. Question number 38. I think there is some problem in the figure. I have drawn it here for you. the same figure I have reciprocated here. So tension at AB. So it's very simple. They have asked the values of AB and AC. AB and AC. So this is 60. I think this is 90 degree. They have not mentioned, but I've seen somewhere. This is 30. Okay. So you just put the formula and you will get the answer. This is just an application of sine law. TAB divided by the opposite to opposite angle to its opposite angle, that 90 plus 30 sine 120. TAC opposite, that is 90 plus 60 150. 600 they have given 600 Newton here, divided by the opposite angle, that is sine 90. Just put the formula. TAB is equal to 520 Newton and TAC will be 300 Newton. So it will be 520 and 300 option. Question number 39. It's put the formula, get the answer. Yeah, it was simply simple. There is no such otherwise, if you don't know what is sine formula and all, you just means you make the horizontal component and vertical component, equate it, and you will get it. Okay, that means TAC cos 30 degree is equal to TAB cos 60 degree. Then TAC sine 30 degree plus TAB sine 60 degree is equal to 600. If you solve those two equations, you will get the corresponding value of 2AB and AC. Now question number 39. Question number 39. This is the match the following type. Higher kinematic pair. So what they make? They make line contact. Okay. Lower kinematic pair, they make surface contact. Okay. So higher kinetic pair includes cams. Then to some extent I would say pulley. Okay. So these are example of higher kinematic pair. There are many pairs which makes a point contact. Then lower kinetic pair must surface contact, like a any sliding pair. Okay. Now quick return mechanism is in shaper, planar. These have a quick return mechanism. And mobility is something related to Grubler's equation. That is nothing but 3 into n minus 1 minus 2j minus h is the degrees of freedom. Okay. So higher kinetic pair is a line. Lower kinetic pair surface contact means 2 6. Option A or option D. Are quick return mechanism, shaper mechanism. Mobility of the linkage, Grubler's criteria. Option D. Actually, they have mentioned, I want to clarify. They have given two things, planar or shaper. See, planar is actually Whitworth quick return mechanism. Okay. When it comes to only quick return mechanism, we generally go with shaper. There is a difference between quick return. There are two types of quick return mechanism: slider crank quick return mechanism or Whitworth quick return mechanism. This shaper is a slider crank quick return mechanism, and planar is a Whitworth type of quick return mechanism. If I get a time to explain you, I will explain it. But right now, just remember in this question, quick return mechanism, it's generally shaper is responsible. Okay. In this shaper, the adjacent to the smallest link is fixed. Okay, we will solve few questions based on that, but just remember this. This is a slider crank quick return mechanism, and where adjacent to the smallest link is fixed in shaper. Now coming to the question number 40, it's the same question that has been asked previously. It is something related to the transmissibility ratio. So mass of 250 kg mass, machine of 250 kg mass is supported on a spring of a total stiffness 100 kilonewton per meter. Machine has an unbalanced rotating force of 350 Newton at a speed of 360 RPM. Assuming the damping factor to be 0.15, the value of transmissibility ratio is. So we know that transmissibility ratio is equal to square root of 1 plus 2 zeta r whole square divided by square root of 1 minus r square plus 2 zeta r, where zeta is equal to c by cc and r is equal to omega by omega n. Have they given anything related to damping and all? Yes, they have given damping factor 0.15. So zeta will be 0.15, and omega by r we will find omega by omega n. What is omega by omega n? Omega n we can calculate square root of k by m. Omega n is equal to square root of k by, I think I've no, this is square root of k by m, 100 kilonewton, right? Yeah, this is square root of k by m. This is omega in terms of seconds, rps I've calculated. So this is r, the ratio that we have calculated, and then put it and we calculate the transmissibility ratio. See, this question may look very simple at the beginning, but when you are solving it in a gate calculator, which is quite cumbersome, it is very difficult to get the answer. So please practice, because it took me nearly 2 or 3 times to solve and get this answer for that. Okay, and that's what we need to practice this month. Now question number 41. The 4 bar linkages, S denotes the shortest link, L is the longest link, P and Q are the other 2 links. At least one of the 3 moving links will rotate 360. As I told you that okay, at least one of the 3 moving links will rotate. Okay, that means, in order to so that means basically it is saying that the one this mechanism, this 4 bar mechanism linkage is following Grubler's Grasshopp's Grasshopp's mechanism of first type. Okay, where where it is executing crank rocker mechanism. At least one means crank rocker mechanism. Okay, so in this case what will happen is, so in this case the minimum criteria for the Grasshopp's first linkage is length of the shortest and longest link should be less than or equal to the sum of the other 2. Okay, so this is the answer, Grasshopp's mechanism. And when we say that at least one of is rotating 360 degree, that actually means it is Grasshopp's mechanism of first type. Question number 42. Question number 42. A 60 mm long, 6 mm thick fillet weld carries a steady load of 15 kilonewton along the weld. The shear stress of the weld material is equal to 200 megapascal. The factor of safety is. Okay, so let me show you how the welding shear stress is calculated. Now, so this the least, or rather we can say the weakest portion of the weld portion is its throat. You see this, the black portion is the throat, which is the weakest one. Okay, now how the shear stress is acting? So when steady load of 15 along the weld, okay, so the weakest portion is this one, and this is the length of the weld, S. So throat thickness, this is throat thickness divided by S is equal to how much? It is cos 45 degree. From here I got the throat thickness is equal to 5 into 0.707. Okay, now shear stress is equal to force of shear divided by the corresponding area. Okay, so that will be force shear stress. Okay, wait, factor of safety is equal to the ultimate stress or yield stress divided by the stress that is required. So what is the required what is the stress that is given here? So this is the throat thickness. Okay, now what is the force what is the stress that is given here? The shear stress that is given here is 15 kilonewton. I think they have mentioned 15 kilonewton. Okay, 16 mm long, 60 mm long, length is 60 mm and 6 mm thick. Okay, I think this is S, right? This is S, so that is 6 mm. So 6 mm, sorry, 6 mm cross 60. Okay, so the shear, where the shear is acting? The shear will be acting here, right? Shear will be acting at this surface, and since this surface is elongated to a very long 60 mm long, this 60 mm long, so total area will be 60 into 6, rather I'm sorry, it will be the throat into this length, that is equal to 0.707 into this weld size. S is the size, that is 6 into 0.707 into this 16. So this is the area that we come across. Okay, so this is the force divided by the area is nothing but the stress that is applied. This is the what we found. And factor of safety, have they given? No. Factor of safety is equal to ultimate stress by the stress applied. Ultimate stress, I think they have given, is equal to 200 MPa. So 200 divided by this entire force, this 15 kilonewton divided by this. So this denominator portion will go in the numerator, and you'll find the factor of safety is equal to 3.393. So 3.393 is option B, 3.4. Okay, so I hope you understand this shear force. I will again make the diagram for shear force. See, this is the place. I will make it in some different color so that it is easy to visualize. You see, this is the place where the shear force has to be calculated. It is a length, okay, because this is my length of the my rod, my plates. Okay, these are the length of my plates. So this is one length, this is one length. It is ranging up to, I think, 60 mm. 60, assuming that the plate is also 60 mm, and I have given some welding across the length. So this is the weakest portion of my throat, and this is the length. Okay, so this is the shearing area. It is nothing but the size of the length they have given, I think 6 right, thick, 6 mm thick. So size is 6 cos 45 degree is the throat, it come throat, and this throat multiplied by the across length. This is what it has done. This is the area. Okay, so force divided by this stress, this area is gives the shear stress, and this shear stress, the ultimate shear stress, I think they even ultimate stress divided by the applied shear stress gives us the factor of safety. This is 3.4. Okay, so question number 43, let us see. A two-dimensional flow field has a velocity along x and y direction given by u is equal to x square t, v is equal to minus 2xyt respectively, where t is in time. Equation of streamline, I think many times we have solved it. Equation of streamline will be del x by ux is equal to del y by v, or rather x component of the velocity and y component of velocity. Just put the formula and we'll get the answer as x square y by c. X square y is equal to constant. Question number 44. The velocity profile of a fully developed laminar flow in a pipe of diameter d is given by u is equal to u0 1 minus 4 r square by capital D square, where r is the radial distance from the center. If the viscosity of the fluid is mu, the pressure drop across the length L will be. Okay, just remember this formula. Delta P, that is change in pressure, is equal to 32 mu V average L by D square. Now here the only thing that we need to find is V average. How you'll find the V average? See, it's a pipe flow, right? So the that means the velocity is varying across the diameter. So and I think they have not mentioned anywhere, but it considered to be steady. That means velocity that is coming in is equal to velocity at going at any cross section. So we can say area at any cross section, since the pipe, so I would take pi r square into u average is equal to, this is the pipe, right? Suppose this is a pipe. This is a very small thickness that I will take. That will be 2 pi r dr into this velocity that they have mentioned, u. I will integrate it. And this u average is how much? U average is equal to, in this complete integration divided by pi r square. This is what it has been done. Here it has, I have done the same thing. And then I will integrate it with respect to 0 to r. I think the limits here is, it is varying. The only thing that is varying is r. Diameter is a constant one. Okay. So I will vary from 0 to r. Once I vary that from 0 to r, I get my V average is equal to u by 2. Once I get the value of u by 2, I put it here. And what I need the pressure drop, right? I will get put the formula, put the value of U average, and will get the this much. So this is the pressure drop that is taking place. Now question number 45. A siphon is drawn. The siphon draws the water from the reservoir and discharges it out to the atmosphere. Here is atmosphere, okay? So you will find the atmosphere pressure uh, two places. Here atmosphere and here also atmosphere. Okay. Now assuming the ideal fluid and the reservoir is large, the velocity of at the point P, velocity at the point P means velocity at this point is in the siphon tube is, okay, so velocity at the siphon tube, okay. Now see, when they say that the fluid the velocity of the reservoir is large, so we generally consider 2 points here, at the surface and at the outlet. At the outlet also there is a no pressure, at the surface also there is no pressure, means atmospheric pressure, okay. Now when they say that the velocity is the container is large, that actually means that the velocity, the flow velocity here I'm asking, saying it's very zero, it's zero rather, okay. And they have given some distribution, height distribution. Here it's h1 with respect to datum, it is h1 h2, and from with respect to datum, this container surface, liquid surface is h1. I'll just apply the Bernoulli's equation, v1 square by 2g plus h1 plus v2 square by 2g plus h2, because p2 and p1 cancels away because they both are atmospheric pressures, okay. V1 intentionally, as I told, it should be taken 0 because as they have told, the container is very large, so we are left with h1 minus h2. Therefore v2 square means here v2 square is equal to square root of 2g h1 minus h2. Therefore the velocity that will be acting, why, so that means here velocity is 2g h1 minus h2. Now you see here, this is a constant pipe, right? There is no such mention that it is varying and all. No, it is, if they have not mentioned anything regarding the varying radius and all, that means it is constant area. So if it is constant area, that means the water that is flowing, this is equal to, it is in steady state, and the area is constant. If the area is constant, velocity here will be equal to the velocity of here. Therefore the velocity at 2 is equal to the velocity at P. That's it. Okay, so question number 46 now. I think what is the answer? h1 minus h2. h2 minus h1. Okay, certainly it will not h1 minus h2 because h1 is small. It will be h2 minus h1. Yeah, it is h2 minus h1. I'm sorry, I made some algebraic mistake. It then h1 will come here. v1 is 0. Yeah, it's correct. It's v2 minus v1. h1 minus h2. Is there any other options related to it? No, they have not mentioned any other options. h1 minus h2. h2 minus h1. Oh, anyways, we will take the magnitude of it, so it doesn't bother us much, because if you look at the options also, they have not mentioned h1 minus h2. However, h1 minus h2 will not give any feasible solution in terms of mathematics. So the only thing that is left is the difference between their height, okay. So it will be h1 minus h2 or h2 minus h1 also. But I'm still seeing if there is any possibility if I can make it. Yeah, it is possible. v1, if I take this side, it should be v1 square actually. v1 square minus v2 square, h2 minus h1, okay. Or if I keep v2 square here itself and I bring v1 square here, which is actually a 0, so it will be h1 minus h2, and then we can get it. So it's, yeah, it's correct actually. I have mentioned it wrong. h2 minus, it should be h2 minus h1. It should be h2 minus h1. Now let us see question number 46. Question number 46. A large hydraulic turbine is to generate 300 kilowatt with a RPM of 1000 RPM under the head of 40 meter. Initial testing. A 1:4 scale model of a turbine operates under the head of 10 meter. The power generated by the model in kilowatt will be. You see, whenever we come across this question, you don't need to be remembering all those formula. You can derive the formula there itself. You see here, we know that power is what? Power is nothing but rho, that is mgh. And how m can be written? Rho into the volumetric volume flow rate, rho into q into g into h, that is rho into velocity into g into h. How velocity can be written? Pi by 4 d square. And how h can be written, or rather velocity can be written square root of gh. Area is written pi by 4 d square, h velocity is square root of gh, and there is h. That means if I write p divided by d square, then h to the power 3 by 2 is nothing but a constant. That means power divided by d square h to the power 3 by 2 of a model is equal to power divided by d square h to the power 3 by 2 of a prototype. Okay, because here you are left with how much? Density, which is constant, because they have not mentioned anything other than water they are where they are testing. Density is constant. Then here gravity is constant, pi by 4 is a constant, root 2 is constant. So only term that we have segregated is p divided by d square h to the power 3 by 2 of a model is equal to power divided by d square h to the power 3 by 2 of a prototype. Okay, now simply put it here, all those things. 300 divided by d of the dp prototype square into hp to the power 3 by 2 is equal to p of the model divided by d square of model into h to the power 3 by 2 of the model. Just put it. And I think they have mentioned scale. So always remember, when they write 1 is to 4, but basically it means the length of the, whenever you will find this expression 1 is to 4 scale, it actually means length of the model divided by length of the prototype. Okay, so that means dm by dp is equal to 1 is to 4 square, hm by hp is equal to, I think they have given head, under the head of this. So what we need to calculate? Power, right? The turbine operates under the head of 10 meter. No, I think, let me check if, yes, actually they have given, right, head is equal to 40 meter and here head of 10 meter. So turbine, that is prototype, is working. Prototype so here it is 40 meter, here it is 10 meter. This is not 1 is to 4. Please don't confuse it with 1 is to 4 here. This is 10 meter of model and 40 meter of prototype. Okay, so you just divide and you will get same 1 by 4 to the power 3 by 2. And solving it, you will get 2 to the 2.34 as my answer. Okay, question number 47. So now let us start with question number 47. The statement concerned with the psychometric chart. So before going to that, I want to explain what actually psychometric chart is. In the recent years, they are asking more questions of psychometric chart. So let me explain that. You see, psychometric chart looks something like this. Okay, if you the different, I have used different colors. I think 1 2 3 4 5 colors I have used, and they represent different things. So I have mentioned here. Okay, so let us see. The green represents the specific humidity. These are horizontal line which represents specific humidity, and this is denoted by, this is denoted on a y-axis. Okay, now first, the psychometric chart curve is something like this. This entire psychometric chart is built at pressure is equal to, what? Atmospheric pressure. Okay, so the pressure present in the psychometric chart for designing all the psychometric chart is 1 atm pressure. Now the green represent, as I said, specific humidity, that is and each division of this is 0.001 kg of water vapor present per kg of dry air. Now these red, slanted red colors represent specific volume. Okay, and each slanting, the spacing between each slanting is 30 gram per kg of dry air. Then these blue color, the vertical blue lines represents the dry bulb temperature. Okay, and it increases in this fashion. Then the curve, if you can see, I think I have not made any specific diagram for relative humidity, but let me make that for you. Make some other color. Okay, So there is a curve, if you can see. No, it will get mixed up with something. Okay, let me try this. There is a curve, sky blue I used. So these are nothing but the relative humidity lines. Okay. So relative humidity is the percentage of water vapor present in the air divided by the maximum percentage of water vapor, that is a saturated state of water that a air can hold. These curvilinear lines are relative humidity line. Now if you observe these black lines represents the wet bulb temperature. Wet bulb temperature also it represents the enthalpy of the, means how, here you will find the enthalpy chart. Enthalpy, okay. Here you will find an enthalpy line. Here you will find the enthalpy line. From here you will get the enthalpy at that particular point of that air. Okay, and also you will represent the wet bulb temperature. Now how the wet bulb temperature, here you will find I have made wet bulb temperature is done like this. Okay, this point is represent the corresponding relative humidity curve, and based on that the below is the temperature, that at that point whatever may be the temperature, it represents the wet bulb temperature. Dry bulb temperature is simply just you at any point the downward the abscissa represents dry bulb temperature. What is dew point? Dew point temperature comes when you will take, suppose this is a point P, you take a horizontal, draw horizontal at the relative humidity of that particular point of that particular air, and you mark it down, it represents dew point temperature. Then what is relative humidity? Relative humidity I have drawn using this is what relative humidity which I have drawn right now, this curvilinear portion, and this is specific humidity. Okay, don't confuse relative humidity with specific humidity, and I have already shown what is specific volume. And yeah, all these, this is nothing but the psychometry chart. I hope it may not be very cumbersome, because if you see there are nearly 1 2 3 4 5, approx 5 colors are used and 5 different properties have been discussed with you. So I hope you understand it. If you don't, please do let me know so that I can make a separate video for this, or else you can check in the YouTube. There are many options available in the YouTube where they have explained properly. Okay, so but understanding the psychometric chart is very very important. I think in one of the previous videos I have also shown you what are the different processes of psychometric chart, and what are the different, how it is represented by it. Okay, now let us move on to our question number 47, I think. So the constant relative humidity lines are uphill straight lines to the right. Constant wet bulb temperature lines are downhill straight to the right. Constant constant relative are uphill straight line. No, these are not uphill straight line. So one is not correct. So I will eliminate the options which contain one. Constant wet bulb temperature lines downhill straight to the right. Downhill straight to the right. Constant specific volume are downhill straight to the right. Yes, option 3 is correct. Now let us see. Option 2 and 3 are correct options, because there is no other option containing 3 and 1. So I think option 3 and 2 and 3 is correct. So constant enthalpy line coincided with the wet bulb temperature line. Constant enthalpy line, wet bulb temperature line. Yes. Just wait. Constant enthalpy line coincides with the wet bulb temperature line. Wet bulb temperature is a black color. Also, yes. Constant, correct. Option 4 is correct. Wait. 4 is a correct statement. 4 is a correct statement. So if I observe it, constant wet bulb temperature downhill straight lines to the right. Downhill straight line to the right. You can say it because yeah, let me reconfirm from my solutions. Constant wet bulb temperature downhill straight to the right. Option 2 is correct. Constant specific volume coincides specific volume coincide with a constant wet bulb. Constant wet bulb temperatures are somewhere like this, right? Constant wet bulb temperature is somewhere like this. So no, so option 4 is not a correct option. Rather, option 2 and 3 are correct. So the correct option for this will be 2 and 3. That is constant wet bulb temperature. Constant wet bulb temperature lines are downhill straight to the right, and constant specific heat volume lines are downhill straight to the right. Okay, so 2 and 3 is the right option. Now question number 48. A 100-watt electric bulb, 100-watt electric bulb switched at an area in the volume rather thermally insulated room. So that means heat is generated inside the system and with this volume. So 100-watt bulbs in this volume, insulated room, that means for 24 hours. Okay, the room temperature at the end, it's very simple, mCp delta T. Okay, so this is the volume. We know that the volume of actually they have not mentioned anything, but the density of the air should be taken as 1, because density of air is nearly 1.2 kg per meter cube. They have not mentioned the density of the air. Otherwise, it will be very simple question. So that means the total energy generated by the electric bulb in 24 hours, that is 100 into 24 into 3600. This is the amount of heat that has been generated, and this much amount of heat, since it's an insulating system, so mCp, sorry, CV, I'm sorry, CV, because it's a volume, right? It's an insulated room with a constant volume. CV delta T, that is T minus, because ultimately the temperature is going to increase, so final temperature minus initial temperature. Okay, so these two values you need to remember. First, the density of the air, and second, the CV, that is 0.717. I'm sure they will be giving the value of this density and CV in the question, so you don't have to worry, but this is the concept behind it. Now question number 49. A thin layer of water in the field is formed after a farmer is watered it. The ambient air conditions and the temperature at 20 degree, relative humidity 5%. So this is the temperature they have given, temperature and saturation pressure that they have given. So neglecting the heat transfer between water and ground, the water temperature in the field after phase equilibrium reaches is. So you see here, again repeating this question, a thin layer of water in a film in the field is formed after the farmer is watered. The ambient condition is temperature is 20 degree and relative humidity is 5%. What is relative humidity? Relative humidity is nothing but mass of the vapor divided by the mass of vapor at saturated state, or we can say pressure of the vapor divided by the pressure of the vapor at saturated conditions. Okay, so from here what we can find the pressure of vapor based on this data. I hope we can see at 20 degree what is saturation pressure they have given. At 20 degree saturation pressure is 2.34. The first thing we can calculate is the pressure of vapor at 5 degrees centigrade, as it is not saturated. Now phase equilibrium means you see the thin layer of water is formed in the field. Okay, so now in the second statement they have the heat transfer between the water and the ground. The water temperature in the field after phase equilibrium has reached. That means saturation pressure has already reached, means saturation pressure is equal to vapor pressure. Okay, that means 0.117. If I look at the graph, if I see 0.117, where it can be found? It can be found between minus 15 degree and minus 10 degree. So using the interpolation technique of mathematics, I can say that my temperature will be minus 15 to minus 10. If I look at the option minus 15 to within minus 15 to minus 10, I will get these three options. So I have to interpolate it. So I will interpolate and find that my temperature of that vapor will be minus 14.46, which is nearly equal to option C, minus 14.46. Okay, now question number 50. A horizontal shaft centrifugal pump lifts water at 65 degrees centigrade. Suction nozzle is 1 meter below the pump center line. The pressure at this point is equal to 200 kilopascal gauge and the velocity is 3 meter per second. Steam tables show that the saturation pressure at 65 is 25 kilopascal and specific volume of saturated liquid is 0.00120 meter cube per kg. So the net positive suction head. Now, net positive suction head is the minimum amount of pressure that is required for a pump to suck the water from the suction pipe to delivery to the delivery section. So before that, I want to make you understand what is NPSH in a mathematical format. So NPSH is, suppose this is my pump. This is my pump. So from the impeller to the delivery head, it is called a delivery pipe. It is called delivery head. Now from the suction pipe or suction to the impeller, it is called suction head. So applying Bernoulli's theorem at the eye of the impeller and the suction, I will get something like this. I will get an equation like this. P1 by rho g. Velocity will be 0 because the reservoir is very large. Height, there is no height because this is the datum. P2 by, plus V2 square by 2g plus there will be some suction head. Okay. Second, there will be some losses in the pipe. Okay. So I will be left with P2 is equal to P1 by rho g at atmospheric pressure. What is P1? P1 is nothing but I think the the atmospheric condition that we can face because it is at the surface. Atmosphere minus V square by 2g plus Hs plus Hf. That means I can say the P of the suction. Here I am actually creating a suction pressure. Then only it is getting sucked up. So the P of the suction is less than the atmosphere. Okay. So NPSH is equal to P2 by rho g. P2 by rho g minus vapor pressure. This is to be remembered. Net positive suction head is equal to P2 by rho g minus vapor pressure. This is the minimum amount of pressure that is required to suck the liquid from through the suction pipe. Now in this case we can say NPSH is equal to pressure head plus static head plus velocity head plus the loss of head that took place in this. So what is pressure head that they have told? So they have told that pressure head, the pressure at this point is equal to 200 kilopascal. So I will convert in terms of head of water. So 200 into 10 power of 3 divided by rho into g. Plus they have also told that the suction nozzle is 1 meter below the pump center line. So I will add 1 meter. It is also with respect to every head, the whatever water head they have mentioned is with respect to water. Okay. Then velocity head they have told it is 3 meter. So I will convert this velocity in terms of head, that is 3 square by 2g, that is 20. Again I reiterate, please don't take the value of g as 10 until unless they have mentioned. If they have not mentioned, please take the accurate value of g, that is 9.8 meter per second square. In order to calculate it, I've taken the value, but please don't do in this case, because in the NAT value, that is numerical ability type questions, you may get even though your concept is correct, you may get your answer out of range. So take this value as g value as 9.81 meter per second square. Then what is this 25 kilopascal? So 25 kilopascal and a specific volume of saturated liquid has been given. So I will be converting this 25 kilopascal also in terms of the pressure head. Okay. So at the end of the that is, this is nothing but the HV, H of the vapor. Okay. This saturation pressure, this So from here I will be getting somewhere related to 24 meters. So therefore answer is 24 meter. Okay. So you might be thinking why they have mentioned here 1 by something. We know that this specific volume is equal to 1 by density. Okay, that means density is equal to 1 by specific volume. So therefore this represents density into this gravity, that is 10. From here you get all this. So what we did is we added all the pressure in and converted them in terms of head. Okay, the one thing that we have yes, we have did everything. I have not mentioned anything, but yes, that's correct. So these all are things that we have added it, and it's 24 meter is the answer. Okay, we have added I have converted all the velocity or head or static head, velocity head and vapor pressure head and added it to form the resultant NPSH. So this 24 is our answer. Now let's move on to the next question, question number 51. Given below is the extract of the steam table. The specific enthalpy of water in kilojoule per kg at 150 bar and 45 degrees centigrade is. Now you see here, when the temperature is 45 degree, you will see the volume. I think what we need to find specific enthalpy, right? Okay, specific enthalpy is 188.1. So here p saturation is 0.9593, but when it comes to 150 bar, its temperature becomes 342. Now you make the diagram first, TS diagram. Based on that we will calculate specific enthalpy of water at 150 bar, 150 bar and 45 degrees centigrade. Now 45 degrees centigrade represent it's in the liquid range. Okay, uh, okay, so it includes these two values, it includes these two things, 150 and 45. Okay, so we will see as we increase the pressure, as we increase as we decrease the pressure. Suppose this is our curve, suppose. Okay, this is our curve. So right now my pressure is 150 bar and it is 45. So what is the saturation pressure at what is the saturation pressure at 150 bar? It is 342. That is, it is very high, 342. What they have, uh, saturation pressure, I think the temperature is 342.24. Okay, 342.24. This is 342.24, but they have mentioned 45 degrees centigrade. 45 centigrade indicates it is this way below. That means we are actually dealing with compressed liquid, because this entire pressure is same. We are dealing with compressed liquid. That means we are dealing with compressed liquid. So the enthalpy will be same as that of, and we know that in the compressed liquid the density does not change appreciably as even though we increase the pressure. That means at 150 at 150 bar, the enthalpy will be same as that of enthalpy of saturated liquid. Okay, if I see here, enthalpy will be once saturated liquid 1610. I'm sorry, it is 188.4 y, 188.45, because at 45 degree you will find saturated liquid is 188.45. Okay, so this is answer will be 188.45. I hope you understand the concept. The concept is this saturated temperature represents this dome, but when it comes to 45 degrees centigrade, it indicates that my situation, my point lies here in a compressed zone. And in we know that in compressed zone the pressure of the liquid, the volume of the liquid doesn't change appreciably. That means the all the properties more or less behaves like a compressed liquid. So its property is same as that of here. That means at 45 degree, what will be the proper enthalpy of the liquid? It will be 188.45, which is our answer. Which is our answer. Now question number 52. Determine the correctness or otherwise following assertion and reason. So this is assertion is reason. In a power plant working in a Rankine cycle, the regenerative feed water heating improves efficiency of the turbine. Correct. Now what is regeneration? Regeneration means using the steam that has been extracted by the turbine uh, and feeding it to the feed water. In this way, what we used to do is we used to give less heat to the boiler. That means we used to consume less amount of coal or any other fuel. Now, the regenerative feed water heating raises the average temperature of heat addition in the Rankine cycle. Correct. This is correct. So both assertion and reason is correct. So if we are increasing the average heat temperature, by this what we have to do, we increase the thermal efficiency also. Okay, it affects the thermal efficiency. Hence, by this we increase the thermal efficiency of our system. Now, question number 53. Determine the correctness or otherwise in assertion reason. Condenser is essential equipment in steam power plant. Yes, the condenser is used to extract the heat that has been taken by the steam that has been expanded after the turbine from the turbine. Now, for the same mass flow rate and same pressure rise, the water pump requires substantially lesser power than steam pressure. Again repeating, for the same mass flow rate and same pressure rise, water pump requires substantially lesser power than the steam compressor? Water pump, absolutely no. The water pump require more power. Why? Because just, for the same mass flow rate, same pressure rise, water pump substantially require less power. Yes, pump requires substantially less. Okay, if I observe the pump carefully, pump and compressor are these two different things. The basic difference between pump and compressor is pumps are used to handle liquids. However, compressor are used to handle gases. Okay, we should not intermingle pump with compressor and compressor with the pump. So pump, when the pressure is increased, that means when the density of the so when the pressure of the liquid is increased, that means the density increase, its volume decreases. So the work done by the pump is V into dP. Okay, so volume of the liquid pump, work done by the liquid pump is way less than the work done by the compressor. Okay, now because in compressor the work is done in the form of this one VdV, V PdV, the change in volume. In the liquid pump it is VdP. Okay, rather in open cases also we generally deal with this case. In open system we deal with this case, but in liquid what happens is there is no such significant change in volume, but in compressor then there is, because we are dealing with gases. So option 2 is also correct, but not the correct reason for it. The condenser is essential equipment of steam power plant because they extract the heat energy from the steam. But here in the second option they have correlated compressor with the pump, which is correct to some extent. It is correct, but not the proper explanation for A. Okay. Now question number 54. See, it's actually multiple match the following. You see, uh, when added to the system, group 2. Okay, heat when added to the system, I will rather you just correlate from the diagram. I will see heat is considered to be positive when you will add to the system. Okay, yeah, heat is considered to be positive when added to the system. It is actually inexact differential. It is a path function and acts at the boundary. Similarly, work when added to the system considered to be negative. It's an inexact differential. Then it's a path function, and the transfer of work and heat takes place at the boundary. So the answer should be FGFH. F E EGFH. EGFH. Option B or option D. Then both are inexact. So I think option D is the answer. Okay. Both are inexact. They are path and just wait. Option D is correct. Okay. Now, question number 55. Group 1 shows the different heat addition process in the power cycle. Likewise, group 2 shows the differential heat removal process. Group 3 lists the power cycles. Okay. Power is constant. So when the pressure is constant, it's called Breton cycle. When temperature is constant, it is called Carnot cycle. And when the uh, in Breton cycle, the pressure ratios are generally taken as constant, and we start with the atmospheric pressure and it ends with the also with the atmospheric pressure. Okay, so pressure constant, Breton cycle. Temperature in Carnot cycle, there are two isothermal process. So temperature constant, it's Carnot cycle. Then P and P, that is pressure and pressure, Rankine cycle. Rankine cycle, yes, there are two stages where the pressure is constant. If pressure is constant, first at boiler, the pressure is constant, and then pressure, temperature is not constant, volume is also not constant. So okay, in Otto cycle the volume is constant, because heat addition at constant volume, heat rejection at constant volume. Okay, so volume Otto, temperature, there are two temperature isothermal process in Carnot cycle, the constant pressure at Breton cycle. So let me match this. PP PS Breton PS5. Let me see Otto VV, constant volume QT2. So QT2, the option 1, the first thing QT2. Looking at the first option itself, like rather looking matching one option, that is say Otto cycle. Otto cycle is constant volume heat addition, constant volume heat rejection. You can mark the option as 1. Okay. Now question 56, with increase in the thickness of insulation around a circular pipe, heat loss in the surrounding is due to. Now here is the explanation for this. With increasing the thickness of the cylindrical pipe, we come across two things. First, there are two resistance acting. First, resistance due to conduction, and second, the resistance due to the convection, the outer atmosphere. Okay, so R conduction increases. When the R conduction increases, what happens to the Q loss? Q loss decreases. When R of the convection decreases, R of the Q loss or due to the convection increases. Now you see here, when I am increasing the number of that is, we are increasing the thickness of insulation, what is actually happening there? When I am increasing the insulation thickness, K is already decreased, because insulation, K is decreased, okay, and R is increasing. Whereas in terms of this convection, what is happening? This is the resistance for the convection. This overall area, we are doing, we are increasing the overall area of our convection. Therefore the Q loss is increasing when we are increasing the lining, the insulation lining. So Q convection in a short sense, when we are increasing the insulation thickness, Q loss due to convection is increasing and Q loss due to conduction decreases. So what we will do, we will take this resultant ratio and divide it with R2, because R2 is our something variable, right? So if I divide it, and then we will get the critical thickness ratio. From here we will derive the critical thickness. Therefore Q loss due to convection increases. Q loss in the convection increases while the conduction decreases. This is the reason. Now question number 57. The ultimate tensile strength of the material is 400 megapascal and elongation up to maximum load is 35%. If the material obeys power law of hardening, then the true stress strain relation in the plastic deformation range is. So the true strain is epsilon T is given by ln 1 plus epsilon. Epsilon is the strain. Now if we put the elongation maximum load is 0.35%, that is 0.35 is our strain. Okay, so I got the ln value 0.303, 0.3 rather. True stress is equal to sigma T is equal to sigma ultimate into 1 plus epsilon. Okay, that is equal to 400 into 1.35. True stress is equal to sigma ultimate into 1 plus epsilon n, that is equal to 1.35, that is equal to 450 megapascal. Now at ultimate strength, n is equal to epsilon T, that is equal to 0.3. Therefore 450 is equal to K epsilon to the power n. From here I get the value of K. K is equal to 774.83. Now sigma is equal to the sigma that they have asked. the true stress strain relation at the plastic deformation range is equal to 774.83 into epsilon to the power 0.3. So this is the relation that we need to care about. 0.30. Okay. So the point that we need to remember is this one. The true stress is equal to sigma true is equal to sigma u into 1 plus epsilon n. Now question number 58. Question number 58 is, in sand casting operation, the total liquid head is maintained constant such that it is equal to the mold height. The time taken to fill the mold with the top gate is TA. If the same mold is filled with the bottom gate, then the time taken is TB. Ignore the time required to fill the runner and frictional effects. Assume the atmospheric pressure at the top of the molten surface. The relation between TA and TB is. Now, what they have given, I have mentioned here. Time taken to fill with the top gate is TA, and time taken to fill the mold with the bottom gate is TB. So liquid head is equal to, now liquid head is equal to mold head. Okay. So now when we say top gating system, what is Vmax? What is the time taken by the top gating system? I have compared here. It is volume of the mold, which is constant in both the cases, into area of the gating into V maximum. Okay. So I will take, so this is V maximum. Now what about the B, that is bottom gating system? In bottom gating system, what happening is, here as soon as the velocity is going up, it is actually varying. So what we generally take the average of these two, V max plus V minimum by 2. Okay. So V minimum, we can tell V minimum as 0. So by this we get the average velocity is V max by 2. Okay. So therefore we are already left with TA is direct inversely proportional to V, or velocity. Here the velocity is V max. By default it is coming V max. Here it is coming V max plus V minimum by 2. If I take the ratio, so T of the top by T bottom is equal to half. So therefore T bottom is equal to twice that of top. Question number 59. A 4 mm thick sheet is rolled with 300 mm diameter rolls to reduce thickness without any change in its width. Yes, because in all the forming operation, the one thing that is remain constant is its volume. Now the frictional effect of the work roll interface is 0.1, that is frictional coefficient mu. The minimum possible thickness for the sheet that produced is in a single pass. That means the maximum possible reduction in the thickness is given by delta H is equal to mu square into R. So they have asked about delta H. Delta H is equal to 0.1 square into 150, that is 1.5 mm. Now what is the minimum possible thickness it can reduce? From 4 mm, and it reduced to 1.5 mm, that is equal to, it reduced to 2.5 mm. So answer is 2.5 mm is the answer. Question 60. In a wire drawing operation, the diameter of a steel wire is reduced from 10 mm to 8 mm. The mean flow stress of a material is 400 megapascal. The ideal force required for the drawing operation is, see, for this you need to remember a formula. This is the formula, that is the ideal force required for drawing is sigma mean into AF, that is final area, into natural log initial area by final area. That is 400 is the mean stress that is acting, 400 megapascal, into pi by 4 into 64, that is initial final area. Final area is how much? 8 mm. So 8 square 64, ln initial area, or initial area by final area. So initial area is pi by 4 d square, right? Okay. So we can write in this way also. It is 100 divided by, it's not like that, rather AF by A. It should be actually 100 divided by final should be 64. Okay, because pi by 4 will be reduced. So if I see here, if I calculate properly, once again, 100 into pi into 64 into, rather I will save it, memory save, 100 divided by 64 ln into memory read It is approximately 8.973. I'm sorry, my answer is wrong. It is 8.973. It is 8.973. Okay, kilonewton. So it is approximately, this is the answer. Okay, actually I did not take the square of it, but let me see. Yes, it is 8.973 kilonewton. Actually, I forgot to take the square, but pi by 4 d1 square, d initial square by pi by 4 d final square, I will be left with 100 by 64 only. Okay, so this is rather I keep it 100 divided by 64. If I solve it, I will be getting 8.973 kilonewton. So this will be the answer. Now, question number 61, I think. 61. Question number 61. So they have given four defects. These are related to the forming. Okay. So wrinkling defect. So if you, yes, I am showing you the how the wrinkling is taking place. Okay, when you are drawing a cup, because of excessive blank holding force, you will find wrinkling. So what I will do, I will simply match it. So I will get P is equal to 6. Only one option is there, wrinkling P6. Okay. Now, what is orange peel? Orange peel is actually, getting a right answer is not a big deal, but understanding the concept behind is important. So what is orange peel? Orange peel is increase in the surface roughness due to the uneven flow or appearance or overly large grain size due to result in annealing of at too high pressure. Okay, so increase in the surface, this is the actual defect of increase in surface roughness. Now stretcher strains, these are non-uniform deformation which results from yield point elongation. Non-uniform deformation which results from yield point elongation. Now what is earring? Earring is something like this. Okay, uneven surface of the cup due to anisotropy, because it means the property is changed with respect to the direction. This is due to anisotropy. These are earring. Now, question number 62. In an arc welding, the voltage and current is given here. The arc heat efficiency is 0.85 and welding speed is 8 mm per second. The net heat input is. So, it's just energy conversion principle. So, this much amount of electric energy is given, but it is only 85% efficient. That means only 85% is actually going to the system. This Q, that means rate at which it is throwing, multiplied by this welding velocity. So from here you get the corresponding heat per unit mm that is required. Now question number 63. In an abrasive grain is viewed if each abrasive grain is viewed as a cutting tool, which of the following represent cutting parameter in common grinding operation? Okay, in common grinding operation. Okay, so for large negative rake angle and low shear angles are generally used in grindings. Okay, and cutting speed is generally 30 meter per second. So in grinding, large negative rake angle is used and low shear angle is used. Now question 64. Arrange the process in increasing order of their maximum removal rate. I have increased more than one. So it is electrochemical machining, electro discharge. So first is electrochemical machining. Electrochemical machining removes maximum, then comes electro discharge machining, then comes ultrasonic machining, then electrode beam machining, then comes laser beam machining. So please remember this sequence. Okay, electrochemical machining has a highest and laser beam machining has a lowest. Question number 65. It's a very important actually. Charpy's test is used to measure the toughness. Knoop test is used to measure the micro hardness. Spiral test is used to measure the fluidity, and cupping test is used to measure the formability. Question number 66. Let me see. Okay, here ECM, right? ECM will be, so maximum in an increasing order. So ECM will be higher. In which option? LBM, ECM. This option D is the correct answer. Here it will be Charpy's test is used for toughness, P4. Knoop test is a micro hardness, Q2. Option D is the correct answer. Then question number 66, Johnson's rule. Okay. Okay, so the manufacturing shop process, sheet metal jobs are there. So the job must pass with the two machines M1 and M2 in that order. The processing time in hour for this job is. You see, first we will apply using Johnson's rule. We will find that what is the sequence of the operation should take place. There are two machines doing the same job in different time period. So you see, what I will do, I will make a box. There are how many processes? 1 2 3 4 5 6 6 jobs are there. 6, I will make 6 box. Now here I will write M1 and here I will write M2. Okay, now I will sequence it. Now first I will see the least time. So least time is what? This least time is 6. 6 is where? M2. So I will keep it near M2. First I will write this 6. I will in the vacant boxes I will write 6 near M2. Then the next operation, that means P operation is finished. Now the next operation is 7 U. Then I will keep again 7 here near M2 side. Then U is finished. U job is finished. Then 8. 8 is, I will keep it near M1. Then this operation is finished. Then 19, 32, 27, 20, 14, 11. 11 T. So I will keep it here. Again I will, this is over. 20, 27, 32, 19 here, and then 20. That means then I will write the corresponding jobs. That is, this represents R, this represents T, this represents S, this represents Q, this represents U, and this represents P. So when so this is the sequence I will be going for this. This is the sequence I will be going. So I will make a box, okay, and in this I will write the sequence. Okay, now this is the in time. This is the machining the machining time that it takes. This is the out time when R is inserted. For machining 2, similarly it will be in time, and similarly it will be the out time. Okay, now when the job is started initially at the time T is equal to 0, machine 1 R will take how much? It will take 8 minutes, or rather 8 hours, right? In hours. Machine 1 takes 8 hours. That means after 8 hours it will be taken out. Okay, now after 8 hours it will be transferred to where? It will be transferred to T. Okay, now comes the machine 2, because this machine once it's finished, then the machine 2 will start working. Now in time is 8. I mean, after 8th hour it will be in time for machine 2. Machine 2 takes the process, the job R, 13. Here if you might get confused with this. Once this R machine is finished, right, the T machine will job will be started in the machine 1. Okay, so machine 1 is vacant after 8th hour till in order to do the Tth job, the T job. But machine 2 will be till then machine 2 will be vacant for 8 hours. After this after this machine will finish, machine 1 will finish, this will go to machine 2. The same product will go to machine 2 and it will be processed. Okay, now the machine 1 is vacant. Now the machine at the 8th hour the T job will be inserted. Then the T job taken by the machine 1 is 11 hour. So after 19th hour the Th job is completed by machine 2. Now in the meantime, if you see in the machine 2 taking the 8th at the 8th hour, whichever is got the job, it takes 13 hours to complete. That means by 21st hour it is not free. Okay, by 24 hours is not free, but the machine was in the meantime machine 1 has already given them at the 19th hour the job T, but for that there will be 2 hours delay in this period. Okay, so the machine 2 can take Tth job only at the 21st hour when it will be finishing the first job. Okay, so then it will take the at the 20th hour I will take 20th hour, then the machine 2 will work for 14 hours in this according to this figure and all, and after 5th hour it will finish the Tth job. In the meantime M1 will after finishing at 19th hour it will take the S job. S job takes how much? 27 hours, and in a 46th hour it will finish. Now you see here machine 2 has already finished in the 35th hour. Now it has to wait for S to complete. In 46th hour when the S job will be completed M1, then machine 2 will start on making. So in this way you will find that so we have to find the optimal make span of the shop. So the optimal make span will be or we can say that when all the job will be finished, then only we can say that we have completed the entire processes. Okay, so we can say this is our final operation, then means this entire operation is completed in 115 minutes. So I hope you understood this sequence. First, using the Johnson's rule, we created the sequence, and then we created the sequence in such a way that after the machine 1 works, then only the machine 2 take the work. If the machine 2 is busy in the meantime, then the end product of the machine 1 has to wait for that particular those particular hours, and then once it is finished, machine 2 will take the job. In that is why there is a sheer delay. See, you see here, if you calculate the machine hours, it took 109 hours to complete its job, in this job. However, machine 2 took the to complete 115 hours. Okay, so you will find that there is, I'm sorry if I make that, I'm sorry, I again sorry for that. If you, in order to calculate the span of each machine, you just add it, these all these values, you simply add it. Okay, in order to get the value of machine 2, you just simply add it. But what they have asked is optimum make span in hours of the shop. So optimum make span for machine 1 and machine 2 will be this. So we were doing question number 67. So in the question number 67, they have given two price codes. Okay, they have given two price codes. First, if we purchase less than 500 units, then the unit price will be 10, and if we purchase greater than 500 units, the unit price will be 9. Okay, of course, if we will purchase more, they will reduce the unit price. Now, the annual demand they have given is 2500 units per year. Ordering cost is 100 per order, and inventory holding cost is 25% of the unit price. Now, what is the optimum order quantity? Now, what we will do is we will first calculate the total cost based on first price quote, that is less than 500. Okay, and then we will calculate the the total cost with respect to the second price quote, that is greater than or equal to 500. So let me take this taking the unit price as 10. For let us say I take the break even point, say 500 units. Okay, because there is no intermediary taking place. Yeah, let me take the price at 500 units. The unit price will be 10. So what I will do is square root of 2 into demand into ordering cost divided by holding cost, that is 2.5, that is 25 divided by 100 into this 10. Okay, because 10 is the unit price, so I will be left with this unit. That means my EOQ is coming 447.21. Now the total cost, how you will find the total cost? Total cost will be this EOQ, the total cost will be demand into the unit cost plus Q by 2 into the holding cost, then D divided by EOQ, that we got Q into ordering cost. If I get 2500 into 10, 447.1 divided by 2 into 2.5. Okay, 2.5 means 25% means we got 2.5. How? 25% means 25 by 100 into this 10, because 10 is the unit price. So I got 2.5. So I will place here 2.5 is the holding cost plus D by Q, that is 2500 divided by 447.1 into 100. So I am getting the total cost of 26,118.03. Now consider the second quote. Okay, again I will take the minimum value, say 500. So the total cost I will be getting is D into unit cost, that is demand into the unit cost, plus Q by 2 into CC, the carrying cost, plus D by Q into ordering cost. So since I have already taken, first I find out that what is the EOQ in this case, where it is less than 500, keeping the unit price 10, and henceforth changing its inventory holding cost. Then here I am taking the minimum value as 500. Here the minimum value was, the value that I found is 447.21, but here I am intentionally taking minimum value as 500 because it is less than or equal to 500. Okay, so demand, that is now demand is 2500, then the quantity that I take is minimum quantity, this 500 by 2 into 9 by 4. How you come across 9 by 4? It is 9 divided into 25%, that is 1 by 4. So 9 by 4 into 2500 divided by 500 into ordering cost. Okay, so this is I'm getting 23,562. What I found is total cost if I purchase 447 units EOQ or based on EOQ is greater than the 2000 if I purchase for 500. So I feel that I found that the total cost for purchasing 500 is actually less at this price code. Therefore, what I will do is the optimum order quantity that I should keep is 500. Okay, so basically what was the concept to remember here is the total cost and the EOQ is the standard formula that we all know. EOQ is equal to square root of 2 into total demand into ordering cost by holding cost. Then total cost is equal to demand into unit cost plus the EOQ quantity divided by 2 into carrying cost plus total demand by EOQ into ordering cost, because this represents the total number of orders that we are doing. This represents the holding. Okay. Now question number 68. A firm is required to procure 3 items PQR. The prices quoted by the 3 items by the supplier S1, S2, S3 are given in the table. The management policy requires each item has to be supplied by only one supplier and only one supplier, only one item. So the minimum total cost procurement of the, so in this case what we will do is we will do a row operation and then column operation. Row operation means we will take the minimum quantity in the row and then subtract it from others. Okay, here the minimum quantity is 110. I will subtract it from the other. So 120 minus 110 is 10. 130 minus 110 is 20. Again, in the same, I will repeat it with the other 2 rows. Now again, I will do the column operations. Okay. Now, the same thing here. The minimum, take the minimum value and subtract it from other. Again, I will take the minimum value, that is, I think 10, and subtract with others. Again, I will take the minimum value and subtract with the other. Okay. Now, once I found it, I found that I found zeros in all the columns, or all the rows and all the columns rather. Okay, so I will first take the 0 value. Okay, and subtract it. Then I will take the minimum value 5 and then take the third largest value, third smallest value. This is 10. 10, 5 and 0, 5 and 10. So these are the 3 values that I got, and the corresponding total cost, these the codes they have mentioned, right? The prices, yeah, I will add up those prices. That is for this zero price code, sorry, for this value, 0 value, the corresponding price code was 110. So I will place here 110. Then second minimum, means this second last is 5. The 5 corresponds to 140th price. I will add 140. Then the third last is 10, add 145. So add 145. If you add 110 plus 140 plus 145, it is 385 is the total price that I got. Therefore, the minimum total cost for the procurement to the firm is 385. Remember, you have to take from each column. Okay, the minimum value of each column. Okay, and since you have taken already the minimum value as 0, so you won't be considering this. Here also you won't be considering this. Here, once you take, this is 10, you won't be considering. So this is the last thing that you can go on. So therefore, the answer is 385. 385 is the answer. Question number 69. A stock list wishes to optimize the number of perishable items he needs to stock in any month of the store. The demand distribution is of a perishable item is. So perishable item means the item or the thing whose value degrades with time. For example, a vegetable or bread. Okay, with time its value degrades because after 1 or 2 days or after certain period of time it has no value, or we can call it as a salvage value in industrial terms. Okay, now so the demand distribution is given here. Demand 2, 3, 4, 5 in terms of units, and probability is 0.1, 0.35, 0.35 and 0.2. So the stock list pays 70 on each item and sells each at 90. If the stock is unsold, that is, it's if it is not sold, he has to sell them at 50, at a loss rather. Then there is no penalty of unfulfilled demand. To maximize the expected profit, the optimum stock level is, now you see here, profit, how much profit if it sells at a very right time, at a very right time, he will make a profit of 20 rupees, okay, because he has purchased for 17. But what loss it will make if it unable to sell? It will be again make a loss of 20. Now what is service level? Here comes the concept of service level. Service level is expected probability of not hitting a stock out during the next perishable cycle, and thus it is also probability of not losing the sales. So here stock level will be 20. That means profit. That means he is going to make the profit out of all scenarios. That is 20 divided by 20 plus 20, because he is making profit of 20 out of these two scenarios. So the probability, the service level is 0.5. Now where you will be getting probability of 0.5? When we will start adding it. That means I will add this probability with this, I will get 0.45. Then I will add it, it will be 0.8. Then I will add it, I will get 1, probability as 1. So when I will be the maximum, so in order to maximize the profit, the optimum stock level, the stock level that I should keep in order to maximize the profit, it should be 4 units. Okay, because 0.5 is actually greater than 3 but less than 4. So it is better to take it is better to take the nearest value, that is equal to it should be greater than 3, because the probability is 0.45 here. Okay, it should be greater than 3. The answer will be 4. So it will be 4 units. Now coming to the 70th question, the table gives the details of the assembly line, workstation and total task time for the workstation in minutes. What is the efficiency of the line? You see the maximum time that one will be taking based on the there is a proverb in English that the strength of the chain lies in its weakest link. Here the weakest link, that means the task which is taking the largest time is this one. Okay, so the total time that will be taken will be 10 only. Okay, 10 into 6, 1 2 3 4 5 6. Say 10 into 6 is the maximum time that it can take. But when we add up the total task of individual workstation, we get 48 as our answer. So efficiency of this line efficiency will be 48 divided by 60, that is equal to 80%. Now question number 71. In an orthogonal machining operation, uncut thickness, chip thickness is 0.5, width of the cut is 5 mm, thrust force is 200, rake angle is 15, cutting speed is 20 meter per minute, chip thickness 0.7, cutting force is 1200 Newton. Now assume Merchant's theory, value of shear angle, shear strain respectively are. Okay, the shear angle, we know that it's tan phi, it's r cos alpha, where alpha is the rake angle divided by 1 minus r sin alpha. So r is the chip thickness ratio, it is always less than 1. So 5 divided by chip thickness 0.7. So just put the formula and you will get the value of shear angle. They have mentioned Merchant's theory, right? It will come, we will see later on. Anyways, shear strain. What is the shear strain? I cannot show it in the figure right now, but still just remember this formula. The shear strain value gamma is equal to cot into shear angle plus tan into shear angle minus rake angle. Again repeating, shear strain gamma is represented as cot into shear angle plus tan into shear minus rake angle. So cot 40.2 plus tan 40.2 minus 15. So shear strain is equal to 1.6535. Now question number 72. Coefficient of friction to the tool chip interface. Okay, you in the other books you might be seeing various seeing various different formula. I would suggest you not to read those formula. You can just derive it. For that you need to understand this Merchant circle. Okay, I think I've already made in the previous year question. I've explained completely this Merchant circle. Please go through those videos. You see, this is alpha, this is rake angle which is making with respect to vertical, this is phi, that is shear angle. So correspond, this is Fs, shear force, perpendicular to it is the normal shear, here is the cutting force, here is the thrust force, here is the friction force, and here is the corresponding normal force, and this is beta, this friction angle. Okay, this is alpha, this is phi, this is beta minus alpha. Now what they have asked is the coefficient of friction at the tool chip. The coefficient of friction is mu, and we can get it with tan beta. So basically we need to find tan beta. We need to find tan beta. So tan beta is so we can find here beta minus alpha is equal to fc minus ft. Okay, so that is tan beta minus alpha, because these all are perpendicular forces. fc, ft, fs, f normal shear, f friction, f normal, these are perpendicular forces. So ft by fc is tan beta minus alpha. We know the value of alpha, and based on that we can find the corresponding value of beta, and based on that we can so tan beta, we know that mu is equal to tan beta, so we get 0.4549 as our answer. 4549, that is 0.46. Here it was shear strain is 1.65. Okay, shear angle I think we have already found, right? Yeah, shear angle is 40.2. Yes. So hence this question is completed. Any other thing that we need to calculate? 73. Okay, another thing is the percentage of total energy dissipated due to friction at the tool chip interface. Okay, for that you need to remember this particular diagram. Okay, so this represents the corresponding velocities that we come across. First is shear velocity, then velocity of the chip, velocity of the cutting. Velocity of the cutting is in this way, then velocity of the shear in this way, and velocity of the chip in this way. Now the angle between the shear velocity and the cutting is given by phi. Velocity of the cutting, here is our tool, here is the rake angle, here you will find the 90 minus alpha, and since the sum of all angles of the triangle is 180 degree, so 180 degree minus 90 minus alpha plus phi. So this is the corresponding angle. This is 180 minus 90 minus alpha minus plus phi. So what we need to find? We need to find the percentage of energy dissipated due to friction. Okay, where the dissipation is taking place. So first of all, we need to find the total energy that is required, right? So how we'll find the total energy? It is nothing but the force required for cutting into velocity of the cutting, F cutting into V cutting. This is the total energy. Now where it is used, now how you calculate the friction energy? So for friction energy we need to calculate the velocity of the chip. How we'll calculate it? The velocity of the chip, so velocity of the shear by sine 90 degree is equal to velocity of cutting by the opposite. This is sine thing and all. So this is the basic formula. You don't need to remember the formula. You please remember this particular diagram. Okay, this diagram is important. So from here we will calculate the velocity of the chip. Okay, now velocity of the chip I calculated it using Science law. Now this is the total energy, as I told you, F of cutting into velocity of the cutting. Now the energy consumption means force of friction into velocity of the chip. So force of friction I think we have already calculated. No, we have not calculated here. So how the force of friction can be calculated? You see here, you don't need to remember any formula. I again say we have already calculated tan beta. Okay, so tan beta, we know that the force of friction by say this one. I think we have already calculated tan beta. So we need to calculate force of friction. Okay, so the one thing that we can calculate based on the cutting force, I think thrust force and cutting force they have given. So based on that we can calculate the value of R, this resultant. This resultant we can calculate. This is nothing but square root of 1200 plus 200 square ka square root. Okay, once we do it, we can find that F friction by R is nothing but cos pi minus beta, that is called sine beta. So this you can find here, force of friction by R. R is nothing but c square plus t square, and sine 24.46. It is nothing but 90 minus the beta and all. So from here we calculate the force of friction, and what is the energy that is required for the friction? It is force of the friction into the shear velocity. The shear velocity, since we are calculating everything in terms of watt, so we will convert this meter into second, that is we will divide it with 60. So we got energy of the friction is 119.71 watt. So what we need to calculate here? We need to calculate the total energy dissipated due to friction. It is this one, 119.71. Okay, so I'm sorry, percentage of total energy, I'm sorry, percentage. So this will be total energy dissipated at the tool chip due to friction. So 119 divided by 400. 119 divided by 400 into 100. So nearly 30% is the energy that is being dissipated due to friction. Question number 74. The planetary gear trains have 4 gears and 1 carrier. The angular velocity of the gears are omega 1, omega 2, omega 3, omega 4. Okay. So the carrier rotates at an angular velocity omega 5. The carrier, this one. So this is actually a epicyclic, rather a reverted gear train. Okay. So what we need to do is, we need to find the carrier rotates at an angular velocity omega 5. The relation between the angular velocity of G1 and G4. G1 and G4. Okay. So we know that suppose D1 is the driver, right? Carrier rotates. Okay. Let us assume that this is a driver and this is driven. Okay. So the speed of the driver and speed of the driven is equal to the products of driven divided by products of driver. Now you see here, these two are externally meshed, and we know that for externally meshed we generally take minus sign. Since both are externally meshed, so it cancels out. Okay. So now what we do, since there is a carrier arm, what we will do, we will simply subtract n5, that is the carrier speed with it. Okay. Once we so this n just we replace with corresponding omega, and you get the equation, that is omega 1 minus omega 5 divided by omega 4 minus omega 5 is equal to 6. This is the answer. Option A is the answer. Now question number 75. If omega 1 is equal to 60 rpm clockwise when looked from left, if omega 1 is rotating at 60 rpm in a clockwise sense, I'm sorry, this is anti-clockwise sense, it is clockwise sense when looked from the left, what is the angular velocity of the carrier and its direction so that the gear 4 rotate in counterclockwise? Gear 4 rotate in counterclockwise. Gear 4 rotate in counterclockwise direction at twice the angular velocity of gear 1. Okay, that means the gear 1 is rotating at 160 clockwise, and gear 2 will be rotating at gear 4 will be rotating at 120 at counterclockwise. So what we will do is, we have to assume, let us say clockwise is equal to positive. Okay, I took clockwise to be positive. You can take clockwise negative also, and counterclockwise positive. So I took clockwise as a positive in a positive sense, counterclockwise a negative sense. So I got one relation that I found here. Okay. And similarly, it's gear 4 is rotating in anti-clockwise and in double the speed. So minus 120. And what need to find? We need to find the angular velocity of gear 1 looked from the left. Angular velocity of the gear 1. Sorry. What is the angular velocity of the carrier? What is the angular velocity of carrier? That is omega 5. What is the angular velocity of the carrier? So we have to find omega 5. So just put the formula, and you will just put the values here, the equation derived, and you will get the corresponding value of omega 5. Omega 5 is giving a negative sense. That means it is rotating at 156 rpm but in counterclockwise direction. Now coming to the 76th, I think. I'm sorry, it is 76th question. 76th question. You see, it's a simply supported bending beam. This span 6 meter and 75 mm diameter carries a uniformly distributed load. Maximum bending moment, there is a simple formula. It's better to prove it, to find the formula. You see, what you do is, you take an arbitrary section, and this is a sagging moment if you take from the left hand side, you take a sagging moment mx. The reactions that we have calculated, because since it's a uniformly distributed, reactions also will be uniformly distributed. So you see here 1.5 kilonewton per meter, and it is 6 meter, so it is 9 kilonewton that is acting here. It will be acting 4.5 kilonewton, that is it will be distributed across its reactions at the ends. So what we will do, we will find the moment at any cross section mx, and this is the resultant small weight that is acting, and this bending moment because of the support. This is the bending moment equation that you will find here. Okay, now what is the maximum bending moment that you will find? The maximum bending moment you will find when at the center, when you will put x is equal to 3. When you put x is equal to 3, you will get 6.75 kilonewton meter. The best way to, there is a shortcut method that is equal to not shortcut method, it's a formula. It is called WL square by 8. Okay, if you put it, you will get the answer, the same answer. So I don't believe that GATE focuses much on formula and all. There are questions where you can just put the formula, but most of the questions that they have asked, you can derive the formula there itself. You don't need to remember all those things. Okay. So mx is equal to 6.75 kilonewton meter. This is the maximum value of bending moment that you can come across. So this is the answer. The answer that they have given is not correct. So I have written my answer. 6.75 into 6.75 kilonewton meter is my answer. Now what is the value of maximum bending stress? Now maximum bending stress, let me evaluate, let me correlate first. What is the relation between maximum bending moment and maximum bending stress? We know that the bending moment formula is m by I is equal to sigma by y, that is sigma is equal to m y by I. Okay. Now that means stress is directly proportional to moment, keeping all other parameters constant. Okay, that means the point where the maximum stress is actually the point of maximum bending moment. So just put the corresponding formula. Just put the corresponding formula of the bending moment, and y will be, since it's a circular, I think circular diameter, y will be 37.5, that is 75 by 2, and d to the power of 4, diameter is 75 to the power of 4, and just put the formula, and the I will be pi by 64 d to the power 4, and you will get the corresponding value of stress, that is 162.98 megapascal is the answer. Okay. Now question number 678. A vibratory system consists of mass 12.5 kg. A spring stiffness K is 1000 Newton per meter. A dashboard of damping coefficient is 15 Newton second per meter. Value of critical damping. What is Cc? It's very simple. There is a small formula. Cc is equal to square root of 2 into square root of Km. 2 into square root of K. K is what? 1000. M is 12.5. Just put it and you will get the critical damping coefficient. Now what is logarithmic decrement? Logarithmic decrement, we can find this. There is a formula. Delta is equal to 2 pi. See, I would request you to write, to remember rather, all the formulas of vibrations, because I don't think you need to derive it at the examination hall. You may not derive it. Okay. So I would suggest you to remember those formula like transmissibility ratio, this logarithmic decrement, omega, then zeta value. All these you need to all those formula, please remember that, because in the vibration most of the time they just give the formula based, they put the question based on formula. Okay. Now the logarithmic decrement, delta is equal to 2 pi epsilon by 2 pi zeta by 1 minus zeta square. Now what is zeta? Zeta is nothing but C by Cc. I think they have given some damping coefficient. C is equal to 15 Newton second per meter, and we know that Cc is equal to 223.60. Just divide it and you will get zeta value is 0.067, and from here you can get the value of delta. Okay, so this is the logarithmic decrement delta, that is 0.4219. Again I am getting something different. I tried more than once and I get the same answer, so I will keep my answer as same. So I'm not getting my answer here, but here I am getting the answer 223.6. Okay. Now question number 80. Actually the showing you the way is important rather than getting the exact answer, because I found that few of the questions I'm not getting the proper answers. Okay. So I just left to you. If you find that if you find anything wrong from my side, do write in the comment section and just mark that question where I'm wrong. Now question number 80. A football is inflated to a gauge pressure of 1 bar when the ambient temperature was 15 degrees centigrade. When the game started next day, the atmospheric pressure, the air temperature of the stadium is 5 degrees centigrade. Assume the volume of the football remains same, constant. It's at 2500 centimeter cube. So this is actually a constant volume question. So when there is constant volume, pressure is directly proportional to temperature. So what we need to calculate? The amount of heat lost by the air in a football at a gauge pressure, and the gauge pressure of the air in the football at the stadium. So this is a constant volume. So P1 V1 is P1 by T1 is equal to P2 by T2. So from here we calculate the corresponding pressure. So remember this pressure, these pressures that we are using is absolute pressure. The gauge pressure will be when we subtract 100 kilopascal, or rather being very exact 101.325 kilopascal. If we subtract, I will be getting somewhere like 0.94 bar. Okay, 0.94 bar, or here it is 0.93 bar. So there are two options that we come across. Now we need to calculate the amount of heat lost. Now the heat lost will be, for that we need to calculate the value of mass. We know that P1 V1 is equal to MRT. So just put it P, this is again, this is absolute pressure, into V, M, R 0.827 kilojoule per kg Kelvin, 288. So here also there is a kilopascal. Here also kilojoule per kg Kelvin. From here I get the value of M. Okay. Now, since the taking football into my system and its volume is constant, so mcv dt, that means I will take the specific heat at constant volume, not at constant pressure. So mcv, I know for air it is 0.717 or 714 into what is the change in temperature from 15 degree to 5 degree. So change in temperature is 10. So q is equal to 43.554. Okay, so answer will be approximately this. Option D is the answer. Now question number 81, the gauge pressure of the air to which the ball must have been originally inflated so that it would be equal to 1 bar gauge at the stadium. Okay, so they are asking P1. Initially the gauge pressure was 1 bar. Okay, if you remember, here they have given 1 bar. Again they are asking what the gauge pressure of air of the ball must have been originally inflated so that it should be equal to 1 bar at the stadium. So simple, P1 by T1 is equal to P2 by T2. So P1 I need to calculate what was the temperature at that time. It was 15 degree, that is equal to 288 Kelvin. Remember, this temperature has to be Kelvin. Now it inflated to how much? It inflated to I think I have calculated here 1.94 bar in terms of bar, right? Yeah, I think sorry, they have given, right, the original, so that equal to 1 bar gauge pressure. 1 bar gauge pressure means 1 bar means 1 bar is equal to 101.325. 1 bar gauge pressure means 2 into 101.325, that is equal to approximately 202. Okay, this should be the final pressure. So this P2 by T2, just put it and you will get the absolute pressure. Remember, this is the this is the absolute pressure that you gauge. Now what they have asked is the gauge pressure of air. So gauge pressure, just multiply it with 101 and you will get it is nearly 108.86, and if I convert in terms of bar, it is nearly 1.07 bar. Now coming to the question number 82. A smooth flat plate with a sharp leading edge is placed along a gas stream at U, that is equal to 10 meter. That is the uniform velocity with which the gas is flowing is 10 meter per second. The thickness of the boundary layer section RS, I think they have given, no, they have not given any diagram, but the diagram is like this. Okay, diagram is like this. I have seen, actually they have the question paper from where it has been downloaded. There are some things are missing here. Actually, though they have not copied the question properly, but anyways, the gas stream flowing U at okay, the thickness of the boundary at RS is 10. This is 10 mm. The breadth of the plate is 1 meter. This breadth is 1 meter. The density of the gas rho is 1 kg per meter cube. Assume that the boundary layer is thin. The two-dimensional follows a linear velocity distribution. So the boundary layer here, the velocity distribution is linear. That is equal to U is equal to capital U y by delta. At the section RS, y is the height from the plate. Okay, mass rate across the cross section QR. Okay, so this is the figure P, Q, R and S. So what is the mass flow rate across the section QR? Okay, so we know that so since it is uniform right now, so since the mass flow rate is constant everywhere, okay, so mass flow rate at the Q will be its integration of rho into U into dA. U means, I think they have given the value of U in terms of capital U into y by delta. Now what is dA? dA is B, that is this width into this width 1 meter into this dy, because this dy is varying. Okay, so here variable is dy. So now what is the mass flow rate? Mass flow rate is, it is varying from 0 to 0 point or rather 10 mm, that we can say it is 0.01. That means the mass flow rate across the QR. So QR, we in order to calculate the mass flow rate across the QR is equal to the mass flow rate across the RS section, we can say. Okay, basically they mean to say this particular portion we need to calculate the mass flow rate. So we will integrate it, that is nothing but density into the corresponding volume at that corresponding volume at that particular cross section, and once we integrate we found it is 0.05 kg per second. Answer is 0.05. Now the integrated drag force on the plate in the PS section, integrated drag force at the PS section, PS drag force. Okay, now for that we know that drag force is somewhere related to momentum. So first we will find the corresponding momentum. Okay, and so momentum, you need to remember this formula. Momentum theta is given by integration 0 to infinity 0 to delta, sorry, delta is a boundary layer thickness, u by u, capital U whole into 1 minus small u by capital U dy. You just put the value of corresponding u by u, and you will get the you just integrate it, integrate over the delta, you will get the momentum thickness. Okay, so the integration, you will get the corresponding value of what, you will get the corresponding value of theta, that is momentum u by u. Okay, now we know that shear stress divided, this is von Karman equation, shear stress divided by rho u square is equal to theta. That means shear stress is equal to delta by 6. I think we have calculated delta theta is delta by 6 into rho u square. So this shear stress is equal to 10. 10 is the mm, I think 10 mm by 1000. 10 mm by 1000. In order to convert in meter, rho is 1 kg per meter square, u is given 10, so into 100. So from here we calculated shear stress is equal to 1 by 6. Now this shear stress, now we need to calculate the drag force. Drag force value will be varying throughout the boundary layer, so it will be b into this dy. Okay, sorry, b into dx rather. So it will be across the length. So they have not mentioned, I think length is 1 meter, and this ps they have not given anything. So the drag force will be acting here, right, in this surface, 1 into 1. Okay, so it will be 1.67 into 1 into 1. Even though I have written tan into b into dx, this dx is varying from this point ps, I think ps, right, ps into this width, this is 1 meter they have given. So the shear stress that is acting at the surface, the drag force, because drag force actually acts at the surface, it is, the area is 1, so 0.167 into 1, that is 0.167 as our answer, which is nearly equal to 0.17. Now question number 84. Yeah, question number, I think these are the two questions left. Now question number 84, they have given a big value, a big table they have given, and we have to find out the expected completion time. Okay, so the expected completion time we need to calculate. Okay, this is a PERT chart. So we will first of all make the diagram. Okay, so based on these values, I won't be able to tell you how I made the diagram, but you see here A is the predecessor of B. So B activity is actually predecessor, P is preceded by A. Similarly, C is also preceded by A. C is predecessor is A. C is preceded by A. Okay, E is preceded by B and C. E is preceded by B and C. Since we cannot connect B and C directly, so we use a dummy variable, dummy constraint. So similarly, D and E is preceded by F. D and E is preceded by F is actually F's predecessor is D and E. Okay, F is the successor of D and E. Okay, so based on that you can make this sequence. Okay, once you make the sequence, the expected time of completion is nothing but the chain, the time that is maximum of all these. So I found that A, C, E, F is taking maximum time, that is 155. So therefore expected time is 155. Now what is standard deviation of the critical path? Now you see here, I calculate it first. First we calculate the critical path, and based on the critical path we calculate the corresponding variance. For example, A variance is 25, C variance is 81, D variance is 9. Sorry, E, right? A, C, E, F. The critical path is, I have not mentioned here, the critical path is A, C, E and F. Okay. Now when the critical path is A, C, E, F, its corresponding variance is A is 25, C is 81, E is 36 and F is 9. Okay, so these are the variance. Now we have to find the standard deviance. We know that deviance is, the standard deviation is equal to square root of summation of variance. So just sum it up and you will find the corresponding standard deviation of this critical path. So it will be square root of 151 days. So this is the answer. Answer is square root of 151 days. So by this, I finished the GATE Mechanical 2006 question. I hope